Good afternoon, everyone. This is Viha Kaur, today's webinar coordinator. I welcome you all for webinar 136, Modern Materials and Technologies for Repairs. Further, I request all the participants to please like, share, and subscribe our YouTube channel to get regular updates. Also, I request all the participants to please put your questions in Q&A box instead of chat box. Today we have a special guest, Mr. Nagar Goje sir. He's Chief Engineer from MMRDA. I request him to inaugurate the webinar and address the audience.
I am Nagar Goje. I am working as a Chief Engineer in MMR. Am I audible? Yeah.
Yes, you're audible. You're audible, sir.
Yes, sir.
Yes, sir. Yes. I am working as a Chief Engineer in MMRD from this 15th of December. Previously, I was working in MSRDC. I am new to this seminar and these persons, so I may not recognize in most of them, only except Jayant Kulkarni. Actually, I am handling repairs and rehabilitation of all the PAPs which are affected due to various infrastructure projects in MMRD. I am looking after 8 different societies or locations having on an average 15 buildings in each society, and nearly one building has got 600 tenements of around 400 square feet area. We are facing major problems like after shifting the tenement PAPs to these tenements, the repairs problem is very severe with less funds available to these repairs. We are having such problems as the tenements, means those who are shifted there, they are having less area, so they change their area according to their required use. Their income group is also very less, so they are not able to maintain their societies. Thirdly, these are the, as it is in Mumbai, they are having a minimum height from 7 story to 12 stories, 15 stories, and in some cases 20 stories. The people living here do not have any severity or knowledge of what they are doing in their tenements. So one who is living on 7th floor, he might do something and which might affect the other persons living in that building. Majorly, sir, we are facing the problems of having repairs like leakages, then common amenities, downtake pipes, and everything. So I found it very necessary to attend this seminar, get new modern techniques, and which will help us and to the all this common around 72,000 tenements people living on to almost 2-3 lakhs people. So I thank Mr. Jayant Kulkarni sir, and I say that this seminar should start now. Yes, sir.
Thank you, sir. Yeah, we go ahead.
Yes, sir. Now, without wasting much time, I quickly introduce our webinar convener, Mr. Jayant Kulkarni, who is founder, member, and managing director at Epicons Consultants since inception 1999. He is BE Civil from VJTI Mumbai. Further, he pursued masters from VJTI Mumbai. His specific areas of interest are construction chemicals, codal provision, seismic retrofitting, tall buildings, concrete mix design, advanced NDT and evaluation, conservation of heritage structures, and Indian aesthetics. Company has successfully completed more than 8,500 projects under his technical and administrative leadership in multiple avenues of civil engineering like structural design, project management, architecture, NDT, and infra. Company has received many prestigious awards. The most respected award is Industry Excellence Award from Institute of Engineers. Now I request Jayan sir to introduce EFC.
Good afternoon, everybody. Am I audible, Viha?
Yes, sir.
I welcome you on behalf of Epicon Friends of Concrete. This unit works under umbrella of Epicons Consultant Private Limited. One of the well-defined objective of Epicons Consultant is imparting technical knowledge to interested parties and society at large. We got ISO certification. However, this particular platform is in working since 1999. Our inspiration goes to our friend, philosopher, and guru, late engineer A.P. Remedios. We started conducting workshops since last 23 years, and we conducted 79 workshops in 23 years, 35 webinars in last 2 years, started webinar series since lockdown through our unit EFC dedicated to training. EFC is an humble effort to create knowledge sharing platform and develop facility for continued education for practicing structural engineers, corporate consultant, government, semi-government authorities, architects, builder, and faculty and student, of course. This is a quick or short graph of whatever webinars we have conducted. Today we are at Modern Material and Technologies for Repairs, webinar 136. And next webinar will be, which is actually missed out number, discussion on first revision of IS 16700, which is on 19th November. Our EFC team consists of, apart from myself, Mr. Anand Kulkarni, Mr. Ravindra Deshpande, Mr. Purulekar, Mr. Parashar Mugi, and Mr. P.P. Pandey. And with this, I conclude the introduction of Epicon Friends of Concrete on behalf of all the staff and our team members. Thank you.
Thank you, sir. Now I introduce our moderators. Our first moderator, Mr. A.S. Parwekar. He is B Civil from SPCE Mumbai. Further, he pursued Masters from MS University, Vadodara. He is working with Epicons Consultants since 1989. He is director at Epicons since 21 years and handling NDT and Structural Assessment Department. He has conducted training programs on NDT for PWD Meta Nasik, ISSC Mumbai, PWD Thane, Sidco Navi Mumbai, and of course webinars of EFC. He was appointed auditor by RMCMA for RMC plants in 2010-12. He worked on more than 2,500 projects, including structural assessment, large volume NDT project, complex challenging structural design project, and infra project. He has developed in-house well-equipped NABL accredited lab with team of 35 engineers and technicians. Now our second moderator, Mr. P.P. Pandey. He is BE Civil from Ravi Shankar University. He is working with Epicons Consultants since 2003 as a senior GM. He is handling project management department. He is hardcore concrete technologist. He has more than 35 years of experience in the field of bridges, piling, infrastructure development, and greenfield project of various categories like residential, commercial, institutional, and industrial. He has hands-on experience of repairs and rehabilitation of use of construction chemicals. I request Jayan sir to give preamble.
How we decided to work on this subject. In fact, it is very much related to sustainability, and sustainability has got 17 goals as decided worldwide. One of the goals is to achieve clean and green environment. There is a substantial or very huge development in civil construction sector, especially in terms of RCC structure of various kinds, industrial, residential, commercial, hospitality. On other side, roads, flyover bridges, dams, etc. in last century. RCC is very commonly used versatile construction material, primarily because of ease of availability of raw materials as well as skilled laborers. Secondly, versatility and flexibility in terms of form, shape, size to be achieved. Thirdly, speed of construction. And fourth is continuous research and development is leading to efficient product. Now, what is the limitation or shortcoming of this RCC? only cement concrete is very stable material. It is having very long life. Once it comes in contact with environmental factors like temperature variation, wind, humidity, or external forces like earthquake, tsunami, fire, etc., then the problem starts. However, if the reinforced cement concrete is actually better in performance but has a limitation of service life, and here the question of sustainability comes. If the structure is affected, then either we need to demolish it or we have to repair it. Especially for increasing service life, there are lots of effort in various directions, right from selection of materials, doing proper mix design, and if at all some problems are found later on, intervention at the right time by proper construction methodologies. Now, what are the limiting factors? Natural composition of cement concrete has inherent micropores and pores. This leads to absorption of water vapors and carbon dioxide. Further, this leads to corrosion of reinforcement steel, ultimately resulting in cracking of concrete member, and in turn, it leads to reduced service life. And corrosion can also be fluoride-induced or galvanic corrosion. Now, there are efforts from various directions, and one of the efforts is to increase the service life of RCC structure. So once we say we want to increase by proper intervention, then we must have proper course. So do we have proper Indian standards or specification for use of modern material? So answer is partially yes, especially for infrastructure. They have reasonably good codes which are available very easily. Partially no, because for normal civil structure, the codes are under development and one or two speakers are also part of the code committee. However, as on today, European codes are available which can be referred and followed as on date. Now we are going to understand from industry expert international codal provision, EN codal provision for various modern material and repair system. These modern materials will enhance service life of the structure if taken at right time. We will also understand how to deal with the chloride-induced corrosion, and finally we'll also understand how to strengthen RCC dilapidated structure and defense mechanism for passive fire resistance. With this, I complete my preamble and request Viha to start.
Thank you, sir. Now I introduce our first speaker, Mr. Samir Surlakar. Mr. Surlakar is a civil and structural engineer with nearly 45 years of global experience in
Can I
concrete.
share my screen? I can show the biodata also.
He already has.
Okay.
He's prepared on this basis.
Okay, no problem. Okay, go ahead.
Thank you.
Go ahead.
Mr. Samir Surlakar is civil and structural engineer with nearly 45 years of global experience in concrete and construction chemicals. He is the founder and director of SS Buildchem Private Limited, a leading manufacturer of construction chemicals. He pioneered construction chemicals manufacturing in India in mid-1980s. He has been conferred the ACC Gaurav Award, Outstanding Contribution to Concrete Technology Award, and ICI Outstanding Concrete Engineer Award, amongst many others. He co-authored Handbook of Advanced Concrete Technology, ICI Handbook on Admixture, Waterproofing and Industrial Floorings. He is member of BIS and IRC B8 Committee. He is the past president of CCMA, VP of ICI, Director of India Chapter of ACI, held key position in IIT UP, ACCE, and is Chief Coordinator of ECI and CIDC. I welcome Mr. Samir Surlakar and request him to start the lecture. Thank you.
Good afternoon. I am audible?
Yes, sir. Good afternoon.
Good afternoon, professionals. First of all, I thank you. I thank Neha for introducing me. In fact, I had my own biodata, but anyway, this is my basic business card. But she has told you most of the things. I also thank Epicons Friends of Concrete. And the friend of concrete is also my friend from VJTI. I really congratulate Epicons for conducting and disseminating so much of knowledge through their workshops and training programs that he's really, I think no other person in the field of construction has done that. Now also he has chosen a very, very apt topic. And as Mr. Nagarole rightly said, that the problems of repairs are very difficult problems on the surface of it. I shall try to make it as easy as possible. My presentation does not contain much of chemical equations and things like that. So I'll be coming straight to the main point. Concrete is the material that we are going to talk about. And as Mr. Jayant rightly mentioned, concrete has got its problems. It is very porous. And this porosity is one of the main reasons why the deterioration mechanism takes place. Concrete has got two very simple things. It has got cracks and capillaries. It is a water-based system. You can't avoid it. These are the different causes of deterioration, which also mentioned subtly. And it's enough that not to go into details as I'm talking to the professional. There is more knowledge facing me than facing you. You all are experts, professionals who have got a lot of experience in the field. So I don't think we should waste our time in some basic things. This is the deterioration of the concrete is a normal thing. It's a fallacy for us to assume that we can cast a concrete and just leave it like that to fend it for its service life of 150 years. It requires a very strong and a healthy asset management system. And this is exactly what we are missing in our country. We create the structures, but there is no asset management systems. Therefore, there are no budgets provided for asset management. And that is one of the reasons why you see most of our structures, they are distressed. A very simple thing, what happens is it's the carbon dioxide chlorides and the water that creates a corrosion. Basically, what happens is concrete is a basic system. The whole protection to concrete comes from its cover. That's the whole concept. This is so simple. But in reality, in our country or any other place, the concrete cover, which is supposed to be one of the best part of the structure, so that it is directly in contact with the environment and the concrete interaction stage, is one of the worst parts. It is having 0.1 water cement ratio more, and it is having 45 kg per cubic meter less. So this is how the concrete cover starts getting breached through carbonation or chlorides. Basically, to take precautions, we should have very good quality spacers, bar spacers. We are using bar spacers that they are not healthy. If you have a look at it, these are very healthy bar spacers. Bar spacers have also got a code of practice, and these are tested. These bar spacers are of good quality. These are tested. This is approved even by the bullet train project. It is tested for sustainability. That means this is made out of green concrete, and it is tested for durability. That is for rapid chloride testing. So use a good quality. Then the simple corrosion, what we were taught in SSC. Corrosion involves most important thing. It involves chemistry, electricity. It goes through two stages: initiation and propagation. It's basically such a simple topic which you have tried to complicate by using people's psychological maintenance system, telling you something complicated about. It's a very, very simple thing to repair the concrete. And the code EN 1504 makes it very, very simple, uncomplicated. I would say to the extent it is almost non-engineering. Carbonation is nothing, but since there is a constant acid rain, the pH of the concrete starts shifting from 13.2, and the reinforcement bar, which is used to stay in the alkaline condition, starts getting into the acidic zone, and the rusting starts. Such a simple process. By rusting, what happens in physically is the volume expands up to about 7 times. Concrete is not so good, or concrete is bad in tensile stresses. So eventually the cover gets cracked. Once the first crack occurs, more deleterious substances, more acids enter the reinforcement and enter the concrete, and the rusting starts. The corrosion controlling constituents which create the corrosion and the rusting are to be arrested. And once when you repair, the main thing is to stop that corrosion at that status quo. So this is due to carbonation. With chlorides, it is little bit dangerous because there you get something called corrosion by pitting, and pitting is you get a say it's away the reinforcement and the section goes tremendously low. So this normally happens in marine conditions, or also many buildings in our Bandra city, our not Bandra ceiling here. What is that area? Bandakula complex. There many structures are having a lot of chlorides. It looks the concrete they used, as well as they used some salt water even for making the concrete. So there were some researchers and all. What happens? All this dampness water appears on the inside of the concrete. The failure of waterproofing is not when the water is seen on the other proofing or beginning of repairs, is when enters calculated. So it is need and platforms today in which I'm not talking about 360, but there are more danger, more easy scale platforms in which all taking 20, 30, the failure tests, and even one under the taking the course of diffusion. So you exactly know how much time it will be rushed. Now we are having these tools are available to us. So my request to top level people like Mr. Agarwal and the MMRDA and the specification maker and the consultants, please use these tools. Please use these tools to find out what is the residual life of the structures. These tools continue to give you the systems of repairs, even in the systems of repairs which are highly dependent on the money available. It can tell you that if you make X repairs, it will remain for 5 years. If you make Y repairs, it will remain for 10 years. If you want to remain it for 40 years, this is the method to be adopted. I think for a country like ours, with limited resources, this will be the thing. Now, this is what happens. The water comes, and this is another major problem that building societies and Mr. Nagarwal, Mr. Sen, the water which is exhibited inside your house, which is coming from the wet areas of top level person. It is very unfortunate because we have constructed it by fault. And sometimes what happens in many new buildings, we have to make the toilets blocks in the places where it is not provided. So I shall also be touching this thing very shortly as the time passes, but this is what happens. And the person on top of you, he does not allow you to touch. He said, nothing is happening to me unless something starts from his top. And this is the next step. This is what Mr. Jayant Kulkarni very, very rightly said, using right material at right time. Once the time passes, the normal aesthetic repairs, what we showed, the aesthetic thing, and not looking good water, it goes to stage 2, stage 3, and we wait. until we reach a stage when the structures is totally deteriorated. So this is what happens. This is a very, very common occurrence in most of the buildings. Then we try to repair it. Of course, please see unprofessionally. I think I will mostly I will be talking, since I'm talking to top level people, I'll be talking. We need professional structural engineers. We need professional and trained applicators. We need proper specifications which are not based on research and development, as the specifications should be with the existing codes of practice, and the codes are existing not only in foreign countries, but the codes are also existing in our own country. But still the specifications in our country in some projects, I'm talking present tense, are highly guided by the prescriptive methods. So I request people like MMRDA to please change this. This is what happens when we wait, and then we have all this. You can see the structures lingering at the brinks of destructions, and that time we raise up, and then we want to repair it. And then it also costs a hell of a lot of money. In fact, one of the nice things that Mr. Agarwal said, basically many people tell you to talk about repairs, but repairs and waterproofing cannot be separated. It is a vicious circle, and waterproofing is a wrong word for it. Concrete needs to be protected if you want to leave it for 150 years of its design life in the service conditions, and the protection is directly proportional to the type of the environment it is exposed to you. The environmental classes are mentioned in our course of practice. So I would say repair, protection, and corrosion. So we have two types of things. We have waterproofing, which is preventive, which I think we are not here to talk more, but even if you want to shift a toilet, I said just touch that portion, and rest of what we are doing is everything remedial. Remedial waterproofing is nothing but repairs. I think this is how these things are connected. So these are the options that we have when you have the problems, and it depends on how much money the owners have. Do nothing, downgrade the structures, which is not very possible. Repair and restore, part reconstruction, and demolition. So sometimes what happens, this is one of the latest structures which has been built. We should really meet this engineer and ask him how did he build it. And this is the present. This photo came to me just 2 days back. I can stop it, but probably stopping this water will cost you more than demolishing the structure and rebuilding. So here some punitive action or some legislation is necessary. This, as I said, this photo came only day before yesterday. So the logical steps of action is concrete. We don't have that much money. Bridges cannot be just thrown out. So concrete needs to be repaired. Then how do we do it? So materials are the key. The materials are the key. In spite of it, please do not take, I'm a construction chemical manufacturer. I've been a president of CCMA for 5 years, active member. Please do not take specifications from construction chemical manufacturers. Please take, we do not supply any construction chemicals as a part of our policy, since Mr. Jain talked about his policy. We supply the materials to repair only when a structural consultant has given his okay. It's not my job. My job is only to make a material of the properties as decided by the structural consultant. It is basically engineering, not materials. I make the materials, and now the biggest problem in the world is the durability of the repairs. Those days are gone. Now people are making repairs, and when they make it with wrong materials, not stopping the corrosion, then the durability is affected. And that is costing the country more and more and more and more of money. I think this should be stopped. Now, this is one simple test which I did in BRC. There was a specification that time about 25 years back when he said, what is to be done? He said, first clean the reinforcement with some acid, which is not allowed. As per the NEEP EN code, no chemical methods are allowed to clean the reinforcement, only mechanical. You can rust converter is not a rust remover. I shall also show you what is the development in that a little bit when I come to it. There are ways, but they are not rust converter. Rust converter means instead of Fe2O3, if you make it Fe2P3. Then he said the thing 20% SBR solution or acrylic solution, cure all. That means one pill for all the things. We did this, and I said just keep it below your. It was repaired. There's a reinforcement here, reinforcement here. Within about a week or 2 weeks time, the crack surfaced. It's very easy to identify a repair crack which comes through reinforcement. It is straight. And then they change the specifications. Now, these are the first signs. You can see it. And this is also, I would like to mention, this is in our own college, BJTI. This column was repaired by some odd methods with all the things available. So I told him, no, this is not the right way. And within 3 months' time, I took the photo before the corrosion. That means repair is of no use until and unless the corrosion is totally stopped. You see here, this is repaired. And now what is that? This is another attempt which is where the structural, where the non-professional person did not involve any structural person. And he started breaking down the column without this on the ground floor. This was ground plus 6 building. You can see the buckling. And then we think, oh, char danda dal do, which is a point load. So this is the standard statement. Most of the statements I have not said. Everywhere down below, I think they are recording it also. The sources are given. 25% of the structural owners are unhappy with the performance of the repair and protection material. Within 5 years, so and so, 75% are dissatisfied within 10 years. And this is exactly where our money is drained out. And this is another building which is collapsed. The only thing, those of you at our age, maybe about 20 years back, know this thing. The same person was their structural engineer. The same person was the contractor, and the same person was the manufacturer of construction chemicals. Now, this is the famous de Sitas law. If you don't do normal maintenance, perpetual maintenance is the key to the durability. Eternal maintenance is the key to the durability of the car. If you don't do normal maintenance, you will be required to do the repairs, which will cost you 5 times more than normal maintenance. If you don't do repairs, you will have to replace, which will cost you 5 times more. So these are standard, everyone knows it. So we should change it. This is the way to go about it. It is one of the old thing. So first, all the NDT, where Epicons and other companies, they can do all the NDT testing. After doing the testing, normally they give you big 50, 60 page reports and they say what has happened. It's same like you go to a doctor, he gives you ECG and it is all in different colors, but you don't know what is to be done. The aim of diagnosis is only to find out what is the loss of section. If the section of the bar as designed and as existing today is less than 80%, it is a structural repair. Both the steps overlap. There is a lot of difference between what is repairs, rehabilitation, restoration, retrofitting, and strengthening. These are 5 different things. These are all mixed up. For the sake of making money or for the sake of things where only repair is to be done, we use retrofitting methods. And this is the drain on our resources. So this can be only stopped when you start using the prevalent codes of practice. They are so non-ambiguous that even a 10th standard or 12th standard student and a good supervisor can suggest what is the repairs. It is very simple. Repair means nothing. Repair means creation or recreation of cover. Either you can create it, whether you say ganiting, whether you say jacketing, whether you say replacing, reprofiling. But when you cannot do it, then we have to resort to a coating, which is also calculated. It can be calculated that X thickness of a protective coating. The protective coating varies from Jammu and Kashmir to the sea. What happens? This gives you something called equivalent cover. This can be all tested in India and it can be done in India. It is so simple. What is important is you have to recreate the integrity. A good bond coat is required. Anyway, I'll just go a little bit quick. So any repair system designed by a predetermined materials in mind will lead to a failure. You go anywhere and you find anything, you find a column which is distressed. अरे बोला ये को कार्बन फाइबर दे लो 300 grams per square meter, उसको एपॉक्सी लगाओ, उसको साड़ी बांध दो, उससे रिपेयर नहीं होता है साहब, unless the inside reaction is stopped. So please be careful. So information is as per EN 1504 is the existing one of the best codes in the world. And please note, I have nothing against America or ACI codes. In ACI, most of the repairs is due to chlorides. To us, more relevant are the EN codes, European norms codes. These are all under ISO. Now, this provides, and this is a beautiful document. We are also trying to adapt it. One or two parts we have already started adapting it in BIS, and we are also writing at the moment 2 handbooks, one for infrastructure. ICI is also writing a handbook on repairs and rehabilitation. We are also writing one, trying to write a handbook with BIS. So maybe soon you will have, but in meantime, this you can use it. So this is such a beautiful thing. I will not go in details. It has got terms, is definitions. Surface protection of the concrete. See, the very first is surface protection. Because you have to find out what is the residual life, and the only thing that can enhance the life of that is civil engineering asset is by using a protection coating, which is available in India. It has got a specification by IRC. We have put it in IRC B8 committee, SP 80, SP 40. It is in orange book. So please take that specification rather than writing your own specifications like interpenetrating networks, phenolic epoxy, reticulant based something. So these are only English literature. It doesn't say how much is anti-carbonation. Their engineers must have empirical values. Those empirical values are well established all over the world for past 25 years. So we still give prescriptive specifications. Now you can say it is an acrylic, because acrylic is automatically resistant to ultraviolet rays. So structural and non-structural repairs, it separates. Structural strengthening is a totally different thing. Concrete injection, which plays a main role. I will just touch it also. The anchoring of reinforcement bars, this is very important when you are connecting the structures. Reinforcement, corrosion protection, very, very important, because you have to stop the corrosion at least at the status quo. Quality control and evaluation and conformity. That means before you do some testing, after all also you do some testing. The general principles for use of products and systems, that means there is a CE marking, which should also come to our country. So part 2 says surface protection systems of concrete. Part 3 structural repairs. Part 4 is structural strengthening. Part 5 is injections. 6 is anchoring. And depending on these principles, we generate the products. Principle 1, principle 2, it cannot go beyond this. So first you have to format, you have to put whatever by your analysis, by your NDT. The problem at the moment I am facing is goes through principle 5. You automatically get the system. So principle 1 means, just to give an example, protection against ingress of substances. The solution is methodology. Impregnation, hydrophobic coating, surface protection, filling cracks and injection. It doesn't say that if the structure is suffering from principle 1, you go here. You go on adding replace embedment, you go bonded plate reinforcement, you make post tensioning. And this is exactly what happens. If this can be stopped in the country, I shall be very thankful that my 40 minutes or 45 minutes will be used. So this is how to prevent and enforcement corrosion. Different principles existing. Only also we put many things. We put some migrating corrosion inhibitors. We are highly influenced. We put some bipolar. It's a very, very simple things. If you can don't have to use it, that they have to be used only when you are talking about a cathodic protection of concrete. Corrosion, sir, you want to ask a question? Hello? Nagaroli, sir, you want to ask a question?
No, sir. No, sir. No.
Okay, because I saw your hand.
No, no.
So this is the thing. We don't have to use it. I saw a specification in Goa. You'll be shocked. It is Goa, our building of Kala Academy, which I think Mr. Jain knows well. It is a 10,000 square meter area. My migrating corrosion inhibitor is specified. A repair which could have been done in 3 or 4 crores is done in 49 crores. And now it is gone for inquiry. It's very unfortunate in the country which we don't have money. We are going into these things. But this is very, very clear now. Know the principle. The replies are, this part is made by us. This part is made by the material manufacturers. Whether you go to us or you go to SICA or whether you go to BSF, you will get the same answers. Go to ethical companies, go to ethical engineers, and then I think you'll be able to save a lot of money. So these are cracks that you know. Cracks means injections. In India, there were only epoxy injections. No, epoxy is already gone out. Once upon a time, epoxy was the only thing which is having strength. But today we have structural polyurethanes. Polyurethanes are more compatible with water. Epoxies are not compatible. Many people will tell you when you make anti-carbonation coating, my epoxies are available in ultraviolet. Yes, epoxies are available in ultraviolet radiation resistance. But are you using it? A micaceous red iron oxide primer to be applied on concrete for what? It is a steel bridge specification. Steel and concrete are two different things. So depending on the different type, we have got more than 20 to 30. Other thing in India, which is the wrong thing is created. Everyone thinks PU means a foam. Just to remove this and dispel all this doubt, I made a presentation to CIDC, to government, which is about 30 to 35 minutes, in which I showed what are the different methods of injections. And we have for trained people, these are available in the country. It depends on the width of the crack. It has got several things. These charts I can send you. Which material is to be used in which cracks. And please go to the experts base. We can sit on the same side of the table and argue about it. It is not what is the cost. The very second question is what is the cost? Cost of what? So there are ways. And then there are machineries. When you use modern machinery, modern materials, you have to bring in modern machineries. When you bring modern machineries, you have to get people, modern people trained. I have trained 25 people in Germany for about last 20 to 25 years. And we are the only company who is having applicators all over India, and we can solve any waterproofing problem, including the one I showed at the top. So it's a different type of packers to be used. Injection means what we do, एक कुछ प्लास्टिक का टुकड़ा डालते हैं, उसमें वो किलिक निक्सन का वो 2 बार का प्रेशर. So this is the foam that we are talking about. Foam is the simplest and the most useless material. They will demonstrate you this. Foam is nothing. The life of the foam is only 2 months. Foam is like a foam. The moment it absorbs some water, once again the water starts coming. It's like a sponge. It includes, and then there is a price. Some person says my foam is only 400 rupees, and his is 900 rupees. It depends on the volume factor. We engineers don't even think about it, because the foam which is costing 400 rupees, the expansion factor is only 15. And the expansion factor of the foam that we are talking about for 800 to 900 rupees is 75. That means 5 times. The 900 rupees product, you will require only 20 kilos, whereas you require 100 kilos of 400 material. So please don't get fooled. But this is very impressive. This has got life of 3 months. And waterproofing and the concrete should have a life of more than 150 years. So these are different other type of resins. So please be careful. So these are now other polyurethanes. They are compatible, but they don't foam. These are very flexible. This can be used in the type of this type of problems when the water is coming from the bottom. We did a project here on Park Road Beach, a brand new building. We did about 55 lakhs of repairs, injecting it from the bottom. But it is not a foam. This is by injections. This has got a life of 140 years, engineering life with certifications. Plus, it is sustainable. So this is where the problems comes from. These are the problems in toilet. What happens is, this is the system we have adopted. So water comes in. And these are the modern tools, modern means. Whenever you do repairs, you've got this type of sleeves available. These are also not plastics. These are very special material made by only one company in Germany, and we all buy from them. This is flexible polyolefins. And this is remaining it for 40 years. So this will stop. It is not a rubber. It is not a PVC. The moment someone does it, other person says, I can also. These are the tapes. These are your flashing tapes. If you can use this type of flashing tape at every corner, this can stick in with the tile adhesives. Put a tile here, put a tile here. Water will never go through it. No joint sealant is required. So when you're shifting the position, you can use this on the whole area. You can make a bathroom anywhere where you want by puncturing the slab by using these techniques. I got specifications. I will give it to you, the specifications. Then the normal things to be done. A tile adhesive is very compulsory thing because new tiles don't have the water absorption capacity. You have to have a chemical bonding. And now be careful of the details. You see beautiful engineers. You see now he has put the drain. The drain is not at the bottom. It is on the top. So I think please be careful. Detailing is very important. We got a detailed specifications for all the type of different toilets with all different type of materials. This is for a flat slab. This is for both which are wall mounted. This is for ones which we are already having some problems. You can inject it from the bottom. But different things have got different systems. Then comes the problems from the walls. This also can be solved. Then we have got very, very specialized new plaster admixtures, which can make some beautiful plasters. I don't think we'll have time, but we can use those things. We have also developed specialized plasters which can take a 5 bar pressure. 5 bar means 50 meter pressure. You can simply put it from outside and even water won't go inside. It is hydrophobic. Even when you break it inside, there is a hydrophobicity. So positive waterproofing from negative side. This allows you, the gels allow you to do. If you can't go out, we are in a position to inject from through and through your basement walls. We can go below the basement, on the side of the basement. This is one of the basement 16 meter below, which we did in Bandrakulla complex. You can see it here. I will not run the full videos, but you can see the water coming. This is the 6th basement in Bombay or in Mumbai. But you need right materials, right machineries, and right applicators. This is the machinery. These are the materials. And we have these materials in our country. in about 2 hours or something, it is totally stopped. It is not by putting some clothes inside, some lead inside, some cement inside. This acrylic gels can stop the water within 9 seconds. So these things are available. Please use them to your advantage. Now these are tested. It has got a test report. Now these gels are tested and it is tested for 20 years. The normal gels which has been used in the country has got a life of 3 months. That is poisonous. It harms your groundwater sustainability. This has been tested for 20 years for its expansion and contraction because these are fortified gels. And this has got a life of engineering life of 120 years. We are ingenious. Let us have the engineering life. The other gel is only 3 months and poisonous. And then when it comes to sustainable, I would like to read this. And these are used still in our countries without asking. This is acrylamide, where a big accident took place because this is in public domain, so I don't care. Its name of the company is put here. This is 75 rupees per kilo. You see here. 330,000 kg of milk had to be thrown away. 370 animals have to be slaughtered. 29 private walls were found, and this is in Europe. So every material that you purchase for injection, which is going to come into contact with your groundwater, and especially in places like Himalayas, where our water is so Ganges, water is so pure, please ask for a groundwater safety certificate. Sustainability. So this is the normal. This I'm not going. These are with old materials. This is the steps of repairs. I will wind up within in another 10 minutes, so that don't worry. This is the steps of repairs. Each and every step is important. Surface preparation. Then you have to stop the corrosion, at least at the status quo. These are different ways. It can be, it is natural protection by alkaline, which is the best one. Then the epoxies, then that is the insulation. Then there is a cathodic protection. Different principles, you can use any principle. Now these are very specialized coatings. These coatings can be used for steel bridges. We can repair a steel bridge 100 years old within about 1 day, without mess, without sandblasting, without harming the environment. Now, this is a product which has got a, as it is as per P11, as per EN 1504. It is called oxide converter. It accelerates the process of oxidation. It is an active coating and a barrier coating. It stops the corrosion within 20 minutes. This is the one. You just apply it on the thing, the thing turns to black. It doesn't convert. It stops the process of rusting forever. And then this has got a plastic embedded in 20 minutes. It is also having a surface barrier. So permanent, then bond coat is the most important part, because homogeneity is to be established between old materials and new materials. You can create the motor whichever way. You can cast it. You can put on hand-packed motors. You can use a micro concrete. This is called what we call it concrete replacement. You can do graniting depending on the areas. And now you see the simplicity. People will tell you, please use a material. It should be fiber containing. It should be X containing. It should be Y containing. No, very simple structural repair. The EN 150 mode 1, 2, 3, 4 categories. Structural repair category should be greater than 45 MPas. Category R3 plus durability required. Non-structural repair so and so, that is in heritage. We have also a full range of heritage motors, which is lime based, no cement. It is so simple. So performance criteria must replace the prescriptive criteria. So properties of the cure, you see how simple are the properties. Fresh motor should be have a reduced water demand, quick and complete drying. What they do is to cheat you. They put a microsilica inside. When you put microsilica inside, you get cracks. To stop that cracks, they put fibers inside. And then they give you, it should be fiber. What the hell you have to do? Whether it contains fibers or not. Your job should be, it should be low shrinkage. test the shrinkage, high tensile strength, enough flexibility, and a strong bond. So let us make it very, very, very simple. Please don't do this. This is our answer to structural strengthening. Column गिर रहा है वो धागे से बांध रहा है. But same thing what we are doing. This is the advancement new materials. We are having something called FRCM system, fiber reinforced cementitious matrix. This is not a mesh. This is a net. Epoxies have got shelf life. So when you, not shelf life, pot life. So when it becomes hot, I think our friend is talking on the fire resistant motors. The epoxy start melting, even in Rajasthan, because after 55 degrees, the glass transition changes. This is cement based, so it doesn't burn. There is a code of design. This has to be designed. This is in 2018, Guide to Design and Construction Externally Bonded Fabric. But they don't want to bring it to our country, because they want to cheat you with that with fabric, with the sari wrapping, with epoxy resins, with cementitious motors. Tested for fire resistance. How it is to be done? Very simple. You put a motor, you put a fiber embedded, you close it. And the last part of it, the last step of repairs is a must. It is protection of concrete. Protection of concrete by anti-carbonation or any other coating having chlorides. Because if you see here, your life in years depends solely on carbonation when initiation of corrosion and propagation. It's hardly take 5 minutes. So this is anti-carbonation coatings. You can also measure it engineering wise at a 125 micron of a protective coating performs like 95 centimeter of M30 compound. So always an equivalent cover can be calculated in India, can be tested in India, specified in India. So this is what happens is, I think some people maybe just a time pass for 30 seconds. It is just like optimum protection. See how she looks. If she was not properly protected, those seniors maybe enjoying, juniors may not. She would have been like this. People will be disillusioned to see her here. But a proper protection is required. Snow won't do. Please note, anti-carbonation coating is not painting. Painting is pigment technology. Anti-carbonation coating is like a skin. It allows the external water not to enter your body, but it allows the sweat to go out. They have to be designed, and paint people cannot make it. If you see it here, it should have a crack bridging capacity in bridges. Now, without putting all these things, they will put in, say, it should have interpenetrating network, made 2 coats, 1 coat micaceous iron oxide pigments, 2 coats epoxy, 4th coat polyurethane. So this is nonsense. Because epoxy is not flexible, epoxy is not ultraviolet resistance, epoxy is not breathing capacity. So why do you use it when there are courses of practice? It should be chloride resistant when you are using in coastal conditions and into water. Crack bridging, very, very important for dynamic loads, all our bridges. And we started using this in India about 25 years back. And the bridge that we did in Kerala for HCC is still living. We did the JJ bridge, M75 concrete. Dark consultant who came, this is why do we want it for 75 concrete? We quoted it. He said it will increase the life of the concrete by 36 years. So this is important. Crack bridging capacity can be tested in India. Open to water vapor diffusion, only the contradictory. Water should not go in, but the water vapor should escape. So this is how it is. This is what happens when you have non-breathing coating. You must have seen it in your bathrooms. And this is how it is designed. It is designed like a mesh. So big fishes cannot enter the coating. This is a coating. By virtue of chemistry, and the small fishes, they can escape out. It is like this. Water vapor can go out. because it is having a low molecular. This is the breathable coating. And this, every property can be tested. Engineering empirical test values. We have mentioned it in IRC B8 committee of more than 10 years back. SP80, there are specification, make one line specification. The anti-carbonation coating should be as per IRC SP80, discussion over. It has got 15 properties to be tested. 15 properties. From the specific gravity, from the thickness of the coating, from the dry film thickness, from its solid content, from its type of things, from the color changing, from the recoatability, the tensile strength, very important, elongation, salt spray test for chlorides and crack bridging capacity. Diffusion against carbon dioxide, which is most important, it should be more than 50. Breathing capacity, it should be less than 0.4. When you have the codes, then why let a professor of English to write your specification? This is tested in India. Can be tested at any place. Very simple, 18 tests or 15 tests. We reduced it 3. Still, there was a lot of pressure, but we said, okay, fine. This is the IR spectrum to know it is the same material, quality control. You take 1 kilo sample, keep it with you. He will supply you with some other junk material next time. Get a IR spectrum. It is like thumbprint. This is important. Potholes, this blowhole should be filled. I am finished, Jan, don't worry. Surface should be like this. Still, another 1 minute is still there. This is not putty. People use putty and create problems. This is a cementitious cosmetic repair mortar, should be part of the specifications. These are the bridges. Finished. References. This is a bridge in Kerala, anti-carbonation coating. These are the bridges which we use. This is about almost 20 years back for a LIC building. Last step of repairs is mandatory. You cannot have your specification without anti-carbonation coatings. We have done more than 800 buildings in Bombay with consultants with anti-carbonation. This is in Goa, next to sea. This is another absolutely next to sea, the resort. You are so happy that you coated it from inside also. You have no objections. Heritage structures, they've got breathing capacity. This is a 400-year-old church. It has got a breathing capacity. You cannot apply a paint. Paint peels. The peeling is because of its breathing capacity pushing the coating. This church is directly in Panji, you can see it. It's a beautiful one. We do temples also. We are very close to God. So this is the conclusion. Protect your concrete and steel will take care of itself. Okay. So only one small point which I would like to show is safety. I will only talk on safety and training, another 2 minutes. You see, this is a Goa bridge. A person has coated with scaffolding. He could not get this is Mandeve bridge of Goa. And this is the applicator. And this is a person passing by. I think safety, sustainability, you see here. And there is a trapeze for person to go up there. You see here. Investigative reporting. You see, the tool has fallen. So please don't do it. Proper scaffolding is necessary. You can do it in a proper way. Right way of doing with masks. Safety of the worker is mandatory. Training is more mandatory. I just saw Jayan's slides, so I just added it in between. People always say, why you don't do it properly in India? Training is not available. Training is available. This is our training center in Goa, where we train about 30 engineers, entrepreneurs, supervisors. It is fully equipped. It is approved by CIDC. This is Mr. Dr. P.R. Swaroop. We have got a full manual, 250 pages on repairs and rehabilitation. How to do repairs. This is the training course. This is just about, this is our last one, which we did about a month back. Every person is getting hands-on training. No theory, sir. Every person gets a brush in his hand and coat. Every person is dressed in a proper way with masks. We don't use safety shoes here because it's not necessary. So we got some 5 points. We got trained applicators. They are approved by Construction Industry Development Corporation, part of National Skill Development. These are the group photo after passing the test. There were 38 people, 31 passed. You have to write an examination. Of course, a simple examination of ticking the things. It is half, but you see the way these are the trainers. Unfortunately, I had also filed my application as a trainer, but he did not give it to me. So you see here, and this is the competency certificate which they get. It's very important. This is made mandatory by CPWD, MES, falling behind. I request MMRDA. MMRDA came to our business connect meeting. Mr. Jamadar gave a presentation of Bombay people go into national database. And this is gave a presentation of, and this is made mandatory by CPWD. We also train them out of country, and finally don't do this type of repairs. You see here. This is a tank in one of the things. तो मैं बोला यार ये एक पाँव निकाला इसका. तो बोला साहब बोलते कुत्ते के ऊपर पत्थर मारता है तो कुत्ता भी 3 पाँव से चलता है. So that's all. It should be sustainability. It should be proper. Thank you very much. Thank you.
Sabir, sir.
Yeah.
Yeah.
Not bad.
There are no questions in the question answers box, but anybody wants to put some
What is it?
Question answers. Hello.
Huh?
Can I
Yes.
hear?
Who's calling?
Yeah,
Yes. Who's
hello. Am I audible?
Yes.
Yes, sir.
But who is speaking?
Yeah. Parulekar here.
हाँ बोल परोलेकर. पहले बोलो मैं परोलेकर बात करता हूँ. बोल.
Sorry.
नहीं दिखता नहीं इतना छोटा दिखता है उधर.
Nice presentation.
Thank you.
I am supposed to conduct question answer session, but there are no questions as of now, at least. So anybody wants to ask any question, please put it in question answer box. Otherwise, we'll go ahead.
So everyone has understood, see?
Sir, I have a question.
Uh,
I am Nagar Goje. I have a question.
yeah.
Yes, sir. Most important.
Yes, sir. Your presentation was very useful to us because we do lot of buildings and lot of repair works also.
Thank you.
Sir, we are. I have got a question.
Right.
I think you told us that there is a residual life of concrete and we can measure it with.
Right.
So
we
would
advise or yes.
Yeah, sir. Either you or those who are evaluating the residual life of the building.
Exactly. People like Jain Kulkarni and the consultant, but I know the people. I can give them.
Sir.
Yes.
Yes, sir. I will require those numbers so that
no problem. But at the moment, one of the best platforms is coming to India. They have made some identification with IIT Delhi and IIT Chennai. I am trying to get them inside because of the 360 what people are using in India, that is based on fixed law. That means that is applicable only to the concretes under saturation. Okay. But different concretes in life are under different degrees of saturation. So here you have to take the real core and find out what is the diffusion coefficient. And then you can't do it only 3 tests. You have to do about 25 tests all and then to be fed in the computer. The reply comes out as a system. It shows also 4 or 5 repair methods with respect to economy. But I will be in touch with you through Mr. Jain Kulkarni.
Yes, sir.
We'll take.
Thank you, sir.
One question. We'll go ahead. Somebody, Mr. Raghu has asked for any reference of any books. Big books for repairs and structural on all the repairs of structural and non-structural? Any textbooks maybe say asking for? Any
Yeah,
textbooks are there?
Yeah, one of the best books is written by our friend. I tend to forget his name. I can see the book from here. The best book is by Mr. Vayubhat and Mr. Peter Ammons. One of the best books on repairs is by Peter Ammons, which was written so many years ago. You want me to get the book from there and show you? Peter Ammons is a. I will send you the list.
You please send a list.
Yeah,
which
there are some good books available and there are some bad books available. Please don't use bad books, because whatever is printed does not mean it is right, sir.
So please send a list. Which we can
List means it is hardly few books.
Correct. No issues. You go ahead.
I think we have to go ahead now. Yeah, I think we have to go ahead now. I hand over it to Viha for next.
There is a CPWD handbook also for repair.
Yeah.
Yes, that was written by us also. I was also part of it, but that was when Mr. Panchadari was there, and our Arvind Riker and all, we were involved. But I think that is now, like you said, modern. A lot of things have changed.
If somebody has not read, we should start with that.
Yes. But what happens is, lot of things have changed between my own life of 45 years in construction chemistry. So better to use now the books which are little bit contemporary. Please.
There are some additional questions, but we'll try to answer them at the end because we have to go ahead. Yeah.
So I will excuse myself.
Yeah, sure.
Okay. Fine.
Thank you very much.
Thank you.
Thank you.
Bye bye.
आपको अभी से धन्यवाद कर देता हूँ आप रहेंगे न्यूज़ सुनने के लिए
आपका धन्यवाद सर आंखों पर चलिए thank you very much. We'll be in touch through Jayan. Thank you.
Thank you.
Thank you. Yeah, please go ahead, Viha.
Thank you, Samir sir. Now I'll introduce our second speaker, Mr. Pushpam Kumar. Mr. Pushpam Kumar is currently working as Target Market Head Refurbishment at Sika India Private Limited. He is academically an engineer with Masters in International Marketing from Indian Institute of Foreign Trade. He has been with Sika India since 2011 at various positions to support team refurbishment, product for concrete repair, grounding and fixing, structural strengthening with CFRP and protective coating. He has been instrumental in various repairs and rehabilitation projects of bridges, flyover, buildings, industrial structures like cooling towers and chimney, etc. He has been actively involved in renewable energy project and has successfully done wind tower grounding project. Prior to Sika, he has been associated with an Australian company, Trilorit, and has contributed to structural retrofitting and control dismantling using new generation technologies like diamond saws with hydraulic machines like wall saws and wire saws. With his 23 years of overall experience, he has worked for more than 18 years in concrete repairs and rehabilitation industry. Welcome Mr. Pushpam Kumar and request him to start with the lecture. Thank you.
Thank you, Viha. So, good afternoon, everyone. Thank you, Jan sir. Thank you, everyone. As we have mentioned, I represent Sika. I would just like to give a brief introduction about Sika. Sika is a global multinational company which is working in more than 100 countries with around 27,000 people across the world. Most important part is Sika's involvement is new research and development. Like on the right hand side, you can see in last 1 year, Sika has filed 99 patents and more than 150 new invention disclosure has been filed. So this is one of the most important criteria for any of the modern material manufacturing company. In India, Sika is actively working since last 1987, and today Sika has 8 factories to support Indian market with 400 people across India. I would move to the topic structural strengthening for RCCA structure. And I really thank Mr. Samir, who rightly mentioned that the repair and structural strengthening are two different aspects. And he mentioned in one of his slides that when the reinforcement has corroded, what will happen. So let us understand why we need structural strengthening. This is very important because there should not be a common practice that we do structural strengthening everywhere. So first is when the load is increasing on your structural member. Second is repair of damaged member when the reinforcement has got corroded. For example, if the original reinforcement was 25, 24 dia, and after a certain period of life, the reinforcement has corroded to 15 diameter, means 40% reduction of reinforcement has happened, means the load carrying capacity of the structural member also has gone down. So these reduction in the steel and loss of load carrying capacity has to be compensated by additional reinforcement. Third is modification of a structural system, improvement of structures, or in case if there is any error in design. So these are the basic reason why we need a structural strengthening. There was one study conducted and there was found that more than 75% region was ignorance. Majority of the structure which failed was mainly because of the ignorance. And this is where the importance of training is very, very high, that we need more and more trained people. We need more and more materials so that people understand where we need structural strengthening and what is the role of structural strengthening for any of the RCC structure. In all, any of the structural member, these are the various forces you can see, like tension, compression, shearing, bending, buckling. So these are various forces which are there on the structural member, and we have to strengthen the structural member as per the desired forces. There are various systems available for structural strengthening. One is CFRP, carbon fiber reinforced polymer, which can be used for enhancing the flexural load carrying capacity, shear load carrying capacity, axial load carrying capacity, and seismic strengthening. These carbon fiber materials has got high mechanical properties. Like I would just like to make a comparison with steel. Fe 500, which we use, has a tensile strength of 500 MPa. When you compare with CFRP, these carbon fiber material has got tensile strength of more than 4000 MPa. So roughly around 8 times higher higher tensile strength compared to normal steel. So as an engineer, you can understand we are talking about a product which is having much higher mechanical properties, especially the tensile property. Of course, the modulus of elasticity is also very high, like 230 GPa would like this is similar like steel, and elongation at break is 1.7%. So these carbon fiber laminate or carbon fiber fabric can be used for strengthening of any of the RCC member, but it is very important that we need to identify the tension zone because the CFRP works only in case of tension. So I'll explain in another slide. There are various forms of carbon fiber, CFRP. Like there is a general perception that carbon fiber means only fabric, but no, there are various kind of CFRP. Like you can see on the left hand side, there are circular rods are available, the strips are available, NSM near surface mounting systems are available, and also the carbon fiber wrap, the fabric and different GSMs are available. So these different type of material are used for different application areas. So what happens when this carbon fiber are mixed with epoxy resin, it forms a composite material. And this composite material has got a very high mechanical properties for enhancing the overall load carrying capacity of any of the structural member. Sika is having more than 25 years of working with CFRP across the globe, and on epoxy, Sika is working just more than 50 years, and there are various tests which has already been conducted on the compatibility of CFRP and the epoxy and the interlaminar shear failure. So these are very important aspects that any general epoxy will not be suitable for CFRP application. The epoxy resin which are used for carbon fiber should have a different mechanical properties, should have high glass transition temperature so that it is compatible with CFRP application. I've just made a comparison between FRP versus conventional technique. Like you can see, there was a case wherein 35% increase in the live load was there on the beam member. For this, the conventional method repair was jacketing with micro concrete with 100 millimeter thickness with additional reinforcement of 2 reinforcement of 8 diameter can be used for increasing 35% of live load. The similar kind of application or load carrying capacity enhancement can be done with 6 mm steel plate, or the another option is one single layer of FRP, which has a thickness of 0.12 millimeter. So you can just make a comparison that, in terms of dimensions, these are very effective, and this can increase the load carrying capacity of the structural member, subjected it has been designed and used in the proper way. There is a complete selection criteria that for what application, what kind of material is used. Like you can see here, for a beam flexural strengthening, carbon fiber is the most suitable system. For column, for compression forces or axial load, carbon fiber wrap is most suitable. Similarly, for wall, for flexural strengthening, carbon laminates are most suitable. So we need to understand that which is the best method for strengthening any of the RCC structure with CFRP system. And there are various codes available for this. I would discuss in detail about the testing or the design and the application part. Like in any of the building structure, like frame structure, you can see there are various member and various requirement. You can see, for example, if it is a beam strengthening, for column strengthening, for pre-stress strengthening, like in case of any wall has to be strengthened, or if any cutout is there, if you are making a cutout, we need to strengthen the structural member. If there is any cutout in the slab, we need to strengthen the slab section. So depending upon the application, we can decide that what application would be required with the CFRP system. Like whether it is for building structure or for bridges, various applications are there. Like in case if there is any bridge section for column strengthening, for deck strengthening, for any kind of segmental construction, box strengthening. So various applications are there wherein CFRP can be used. I just have a small video just to show how this works.
Is a carbon fiber reinforced polymer used to allow concrete beams and floors to carry much higher loads. To show how much extra strength Carbadure can add, we set up a simple demonstration in the Sika warehouse. We took two concrete beams, identical in size, about 2 meters long, and in thickness, about 5 centimeters by 5 centimeters. The only difference between them was that one had been reinforced with a Sika Carbadure strip. We placed the unreinforced beam on some concrete pavers, and then asked for a volunteer from the Sika warehouse to see how much weight it could support. Up stepped Peter. And that was the end of it. No surprises there. But then we took the beam that had been reinforced with the Sika Carbadure strip and placed that up on the same supports. On went Peter again. And then Tony. And then Dave. And then Steve. And then Pete.
On the left hand side, you can
And
see
then
the dead
Duncan.
weight. So one beam which was not able to
And
take
then
the load
Mike.
of one person is able to take the
Amazing.
dead weight of.
That's a combined weight of over
And then
600
you can see the
kilograms.
impact load.
So a
the same
concrete
structure
beam,
has to be
which couldn't
strengthened
even
from
support one person,
loading also.
can now support all these people,
So
no
what
problem,
happens, whatever
just by
forces are
adding a
coming on the
single
beam
strip of Sika
is
Carbadure.
getting absorbed by this carbon
Sika
fiber
Carbadure
reinforcement.
makes
See
it
how
easy to
easy
strengthen
the
concrete
application
beams and floors to meet
on
new
the roof
design
slab
loadings
or on the
or
wall.
take heavier
This can
loadings.
be applied.
It's cost
It is
effective, unobtrusive
small
because
in
it's so
dimension,
thin,
1.4
and because it can be
millimeters.
installed so quickly, disruption is minimal. Carbadure, another
This was
smart,
the case
innovative
for
strengthening
beam
solution
section.
from Sika.
Now similar application
Sika is a global leader
for a
in
slab.
structural strengthening systems for the upgrading of concrete and masonry buildings. One innovative Sika product is a carbon fiber plate called Carbadure. Sika Carbadure is a fiber-reinforced polymer used to allow concrete beams and floors to carry much higher loads. To show this, we set up a simple demonstration in the Sika warehouse. First, we took two fiber cement boards identical in size and thickness. The only difference being that one had been reinforced with Sika Carbadure strips. Then we put a 25 kilogram bag onto the unreinforced board. Then another 25 kilograms. And not surprisingly, it broke. No reflection on the fiberboard. It's not designed for this treatment anyway. But then we took the board that had been reinforced with the Sika Carbadur strips. On went 25 kgs. Then 50 kgs. Then 75 kgs. Then 100 kgs. Then on went 80 kgs of Navindra from the Sika warehouse. Not bad. Not bad at all. Then we added another 50 kgs, making a total of 150 kgs plus 80 kgs of Navindra again. Amazing. Sika Carbadur makes it easy to strengthen concrete beams and floors to meet modern design loadings or take heavier loadings. It's cost-effective, unobtrusive because it's so thin, and because it can be installed so quickly, disruption is minimal. Carbadur, another smart, innovative strengthening solution from Sika.
So here you have seen how this has worked for a beam or a slab section. We understand that every member has a different loading requirement, like the slab or the beam was designed for certain flexure load carrying capacity, and later on it was strengthened. So let us understand from the engineering point of view what happens. Like here in case of simply supported beam, when the load is applied, there would be a deflection. So we have to first identify where we have the compression zone and where we have the tension zone. Because as I mentioned initially, carbon fiber work only in case of tension. So we have to first identify the tension zone, and there we can apply this carbon fiber CFRP for increasing the load carrying capacity. So this is the case for simply supported section. Similarly, in case if you have a continuous section, therein you can see the compression zone and tension zone. So depending upon the requirement, you can decide. So like here, where you have the tension zone at the bottom, at the support, you have tension zone at the top. So carbon laminate or carbon fiber has to be used in the tension zone. You can see here at the bottom, and in this case, this is just reversed. On the top, it has been used. So similarly, we need to first identify what is the requirement, where we have the tension zone, and for what application we are using the CFRP for increasing the load carrying capacity. In case of shear, what happens when we have load coming on the beam? If the beam is failing in the shear forces, what happens? It develops a crack at the in the shear zone at an angle. So what happens? Like if you just make a comparison, the reinforcements are either placed vertically or inclined in the shear zone. So what we have to do? We have to increase the shear load carrying capacity or the flexure load carrying capacity for any of the beam section. So let's see first for the bending case. In case of bending, only bottom reinforcement of the beam would be effective. Whatever reinforcement we have provided, but for the bending, only the bottom reinforcement is effective. What happens when the forces are coming? This will take those forces and this will accommodate the structure. So in case if I have to increase the load carrying capacity for bending of a flexure, we can install carbon laminate at the bottom of the beam. Similarly, in case if we have to increase the shear load carrying capacity of any of the beam section, you can see the cracks or the shear forces are there at the shear zone, or this cracks line will develop in case of shear failure. So what we do in case of shear strengthening, the rings which are provided at the shear the shear zone, this is strengthened by CFRP by confining the shear zone. So depending upon the application or the loading requirement, we can decide which product would be used or what application can be done. So effectively, you can see for bending and shear put together, this can be used for increasing the overall load carrying capacity of the beam section. So in general, if I just simplify, for increasing the flexure load carrying capacity, we can install carbon laminate at the bottom, or for increasing the shear load carrying capacity, we can do the confinement at the shear zone. for increasing the shear load carrying capacity, or we can combine together.
Sika is a global leader in structural strengthening systems ideal for the seismic upgrading of concrete and masonry buildings. One innovative Sika product is Sika Wrap, a reinforcing fabric made of either carbon or glass fibres. Sika Wrap is wrapped around columns and bonded to masonry walls, helping a building to withstand much higher earthquake loadings. To help show this, we set up a simple demonstration in the Sika laboratory. First, we took two concrete columns, identical in their size, weight, and compressive strength. The only difference being that one had been wrapped with Sika Wrap. Into the compression tester
And
it
then we are
goes.
doing the compression test. It's a very easy test. It can be done in any of the lab.
On goes the compressive force. And within a very short time, the unwrapped concrete fails. Just as it could in a real-life seismic event.
So you can see 32.97. So 33 MPa with the grade of concrete.
Then we took the column
Now
wrapped in
another
Sika Wrap.
specimen with CFRP. You can see the
On
difference.
goes the compression force. And we wait. At this point, the unwrapped column had failed. When close to double the compressive forces exerted on it, finally, the Sika Wrap column fails.
69.92. So from 33, it is close to
Sika Wrap
70.
makes retrofitting
So
concrete
to
columns
generalize the
easy,
statement
and that makes
you know,
meeting New
just
Zealand's
by
new
doing
earthquake
one layer of
regulations easier
CFRP,
too.
the load
It's
carrying
cost
capacity will
effective,
increase.
unobtrusive
You can
because it's so
understand that
thin,
how it is
and
done.
because it can be installed so
The
quickly,
forces which
disruption
are
is
coming,
minimal.
the axial forces which are
Sika
coming
Wrap,
on the column
another
section,
smart,
this
innovative
is getting absorbed by the CFRP, and the load carrying capacity is increasing. So just as a graphical representation, you can see there is a column section. When the forces are coming, the axial load is coming on the column, the column will try to expand, and there would be a busting tendency in case if it is exceeding the limit. So what we do for taking the additional load, or in case if the reinforcement has corroded or the load carrying capacity has reduced, we do the confinement depending upon the loading requirement. So whatever additional forces are coming, we need to calculate, and for those additional forces, we can do the confinement. So it is a complete engineering behind. There is a design criteria. There is a defined approach for doing the application. So let us understand the design part. Like Sika not only provide only the product or the system solution, Sika also provide design calculation software for doing this design. So this is the software you can see, and this is freely available on the website. These softwares are based on the global guidelines like ACI 450 or TR55 is the code based on which this software is designed. You can see the QR code. If anybody is interested to download the software, you can just use your mobile to scan this QR code and you will get the download link. I can share it later also, but when you download this software on your computer, you can instantly access by pressing the access button. On the right hand side, you can see the access button is given. So there you can directly press and use instantly. But in case if you want the complete software and you want to use it for regular, then you can go to request for online activation. When you click this button, you get a pop-up window. Then you just have to fill your contact detail, email ID, and your contact number. On your email ID, you get the license number, like you can see here, the identification number. This identification number you can insert here, and then you can use this. And the software is completely free. There is no charges for this. You can use it for all the design calculation if you are doing for CFRP application. For any of the application, for axial, bending, or any of the structural member, if you are designing, you can use the software. The advantage of this software is there are various stages of the software. The software would not allow you to go to the next level unless you fulfill all the requirement for the design criteria. So this is one of the important checkpoint within the software, that it would not allow you to go further if you do not enter all the detail properly, or if any of the error is there in the detailing provided. And the software will help you in terms of correcting those details. When you download the software, when you start working, you get the option. As I was mentioning, ACI 440 or TR55, there are various codes available. Using those codes, you can do your design calculation. So first, you get this pop-up window wherein you can select that which code you want to use, which unit you want to use, and then you select the country, because every country has got their different codal provision. So you can select your country so that your design calculation is in compliance with the country requirement. And when you start designing, you get the different stages. Therein you provide the current condition of like here you can see the cross-section detail or the reinforcement detail, the loading detail. And when you provide this loading detail, this will give you an option to calculate. And when you do this calculation, this will give you an output. A detailed report would be shared with you. Instantly, you can download this report from the software itself, and you can see every calculation is provided in the design calculation. Any designer can do manual calculation also, but the software is very effective in terms of quick calculation. So this was on CFRP section, and the next topic which I would be talking on the passive fire protection, and this is also effective for CFRP section, because what happens, the CFRP, carbon fiber reinforced polymer, these are installed with epoxy adhesive, and these epoxy adhesives are very sensitive to higher temperature. So there should be some fire protection. In case of fire, the behavior of CFRP section is different. So we need to protect it for fire situations. So let us understand what is happening today when we are, especially in urbanizing situation, we are going vertical, and when we are going vertical, the risk of fire is increasing, and this fire risk is for people's life. So we need to take proper precaution for fire protection of any of the standard section of RCC structure. So before I go for fire protection, I just have a small video clip. I'll just play how this fire protection works.
Hi, my name's Scott. Everyone knows what firefighters do to keep people and buildings safe, but actually we're just the tip of the iceberg. A building on fire could collapse at any moment. Every second counts. That's why passive fire protection solutions give us extra time to do our job safely.
Fire spreads extremely quickly through a building and is almost impossible to stop. To prevent this, buildings are divided into fire compartments, separated by fire-resistant walls and floors. Joints, pipes, or cables represent leaks from one compartment to another. Sika's fire protection products seal these leaks, which will drastically delay the spread of fire. When it comes to managing a fire, it's not just about the spread of the fire itself. Also, the damage of loaded components plays a significant role. Reinforced concrete, for example, may lose its load-bearing capacity and static stability when exposed to fire. Sika's fire protection mortars delay this happening, as the air encapsulated in the product acts as an insulating layer, gaining valuable time for evacuation. Fire protection mortars are mainly used in underground car parks, tunnels, or industrial facilities.
For me as an architect, reliability is everything. Fire protection is about protecting people's lives, and it's my responsibility to make sure that it's taken into consideration from the very first sketch. We only specify systems that are third-party tested and certified according to relevant international standards.
Sika's passive fire protection systems are tested by accredited international test institutes. In a fire test, a building component, including the relevant Sika solution, is exposed to a fire. During the entire process, temperature and other relevant parameters are recorded. This information is then used to determine the fire resistance time for the element being tested.
As a fire stopping contractor, I am responsible for the correct installation of passive fire protection systems, and Sika is my reliable partner. With on-site trainings, technical documentation, and a wide test scope, they support me to take on this important responsibility.
Passive fire protection plays an essential role in today's building industry. Sika has over 100 years of experience in building excellence from basement to roof, incorporating passive fire protection at every stage.
Our comprehensive fire protection product portfolio and our motivation to protect people, buildings and our environment are reflected in our company ethos, Building Trust.
So here you've seen that how does fire propagate within the building structure. Like the fire happens at one part of the building, and within a short span of time, it goes all across and the complete building is engulfed in the fire. So let us understand why do we need fire protection and where we need fire protection. So tunnels, the confined locations, the high-rise building, apartments, commercial complexes, any of the commercial buildings, especially data centers, server room, the very sensitive area, and the CFRP protected standard sections. So there are various areas where fire protection is required. What happens, like this is one of the case which was in 2017, there was a fire accident in UK and almost 72 people have lost their life. This fire has propagated within 4 hours to the entire building. What happened? There was a detailed investigation. It was found there was a malfunctioning of the fridge on the 4th floor, and there the fire started. But the fire propagated all across, and the complete building was damaged due to the fire, and the people lost their life. And this has sensitized the entire world that now this is high time to review the building regulations and fire safety regulations. So this is very important. We need to understand that how the fire gets across the building and what precautions we have to take. Like compartmentalization is one of the effective way of protecting the building from fire damage. Some of the photographs you can see, one of the industrial building in Bangladesh, there was a fire accident. Because of the fire, the complete building collapsed. Many of the people lost their life, but the building collapsed. Tunnels has long history. Like you can see, many of the people, like more than 700 people have lost their life in tunnel fire. And what happens when the fire accident happens inside the tunnel, the smoke and the fire creates the major hazard. Hospitals is one of the problem area, especially last 2 years, we have seen that more than 100 people have lost their life during the COVID period. So what was happening? All the hospitals were working at the maximum capacity, and because of the AC or other area where the fire was the major challenge, the building has the fire. What happens when the fire happens in any of the hospitals? It is not the end. Like when the building has fire, the building get damaged, and this cannot be used for further users. So what happens? We have to shift the complete hospital to a new building, which is a time-taking process. So this is very important that we need to have a resilient structure where the fire damage cannot go a certain extent which damages the structural member due to the fire, or it can be confined in a very close location. So active fire protection is already in use, like fire sprinklers or the fire extinguishers are already there in the buildings. But today, when we are going vertical and where we are having much critical application, this is not effective alone. We need to have a passive fire protection. So in case of fire, this can be stopped in the confined location, or the structural damage can be controlled within the confined location. So what happens when the fire happens? The concrete does not burn, but when the temperature goes up, like when the temperature increases to 150 or 200 degrees centigrade, the concrete will start getting cracks or delaminated. And because of the continuous fire, this will completely damage. Like when the temperature goes 400 degree and above, the concrete will completely crack and this will delaminate. This will come to a collapse situation. So there was a clear guidelines that in case if we have to strengthen or we have to protect the building structure or any RCC structure from fire, there is a guidelines that the concrete interface temperature should not go beyond 380 °C, or the steel reinforcement which is there inside the RCC structure, it should not cross 250 °C. So these are on the right hand side, you can see the photograph. This is the RCC section wherein within your cover you have the reinforcement and on the top you have this fire protection mortar. Because of this fire protection mortar, the interface temperature between the concrete and the fire protection mortar, the concrete temperature should not go more than 380 °, or the reinforcement which is embedded inside the concrete, it should not increase to 50 °C. And this case of situation should even for 1200 °C, like in case if the fire is of 1200 °C, this should not exceed 380 or 250 °C at concrete interface or steel reinforcement. There are various systems available, like there are penetration seal and there are linear seals available for controlling the fire, for confining in the closed location. And these fire protection systems are certified as per the various international code, like there are European codes or UL standards are there against which these fire protection systems are designed or the fire rating is given. In India, Sika has started fire protection mortar. This is a single component cementitious fire protection system. It contains silicilicate aggregate, and this is very effective for all kind of RCC structure, even for the FRP strengthened section. This is very lightweight material. The density of the material is hardly 500 kg per cubic meter, and this can be used in the layer thickness of 20 to 40 mm depending upon the fire rating. The metal consumption is somewhere around 5 to 6 kg per square meter for 10 mm thickness. So you can see the dead weight is very minimal for protecting the building structure with additional fire protection mortar. And these fire protection mortar has certain properties, like the reaction to fire should be Euroclass A1, or it should have a thermal conductivity or tensile adhesion strength with concrete section is defined as per the various code. This product is tested as per ASTM, and there are clear guidelines, especially one of the tests for compressibility test as per ASTM E136, wherein the specimen is exposed to a fire of 750 °C, and there it is checked that it should not have any impact because of the high temperature of 750 °C. So the compressibility test is done to ensure the mortar it is non-compressible in nature. In addition to this compressibility test, there are various other tests, like for density test or the cohesive bond test, thermal conductivity test, a specific heat test, or deflection test, compressive strength test. There are various tests for which the guidelines are defined, like ASTM codes are available against which this test is done. One of the important tests is RWS fire test. This is one of the tests which is designed for a most worst case scenario wherein the 50 cubic meter fuel is exposed to fire with a fire load of 300 megawatt. And this is done for more than 2 hours or 3 hours section. This test was done for a fire curve of 1200 °C. Like the fire would be for 1200 °C, and therein the performance of the mortar would be tested. So you can see the test specimens, like on the furnace, the concrete block with fire protection mortar is exposed to fire, and this mortar is tested at a regular interval. Like this is 1.5 meter by 1.5 meter section which is exposed to fire, and the fire rating is tested. So here you can see the thermocouples are installed inside the concrete member, and the fire is measured at every 15-second interval. And later a graph is plotted. So the furnace is set at a temperature of 1200 °C, and these thermocouples, which is measuring temperature at every 15 seconds, the graph is plotted. So you can see thermocouple 1, 2, 3, 4, 5, 6, and therein this is tested like steel limit, it is 250 degrees centigrade. It should not exceed 250 degrees centigrade at a steel temperature, or the concrete, the interface temperature should not exceed 380 degrees centigrade. So you can see this is tested for 3-hour fire rating, and the temperature is within the defined limit. So I was talking about CFRP in case of fire. So let's see, there was a test conducted wherein unprotected members were exposed to fire, and it was found that within 60 minutes, the strengthened section has lost its load carrying capacity. And later, the same section was protected with fire protection mortar, and then it was tested and it was found that the load carrying capacity has definitely gone down, but it is still within the limit. Like this red line, if you can see that the minimum expected load carrying capacity, and up to 240 minutes, like for 4 hours, the strengthened section was able to take the desired load. So you can see here on the left hand side photograph, the beam section, which is the concrete, like here you can see the concrete section, which is installed with carbon fiber wrap and the carbon laminate at the bottom. And this section is exposed to fire, and this is tested. So this testing is done as per UL guidelines, and a clear UL certification is done for this fire protection mortar. Some local references you can see here in Vizag refinery, there was a fire accident and the structural member has got damaged. So these structural member later were strengthened with CFRP, and to protect it from further fire hazard, it was protected with Secret 213F with the fireproof mortar. And the another references you can see here in the Hyderabad International Airport project, wherein some of the column members were strengthened with CFRP, and later the CFRP strengthened sections were protected with fire protection mortar. You can see the application. Very easy and simple to apply. This is wet spray applied fire protection mortar, and once the application is done, then that hand troweling is done on the protected surface. And later on, we can do painting or any kind of protective coating we can do on the surface. So with this, I thank you all.
I think we have lost his connectivity. Sir, are you there?
Yes, I am there, sir. Hello? I'm not able to hear you, sir.
Please go ahead.
Yeah. So with this, I conclude the session, sir. From my side, this was my submission. In case if any question answer is there, we can take the questions.
Yeah. Pandit, are you able to take questions? I think my connectivity is low.
Yeah, sure. Is there any question? Question answer?
Yeah, there some few questions are there.
Reducing service life. How can we connect CFRP plate at their ends? This is the question.
Okay. What happens, especially for the beam section, I would take this question because the end connection, end termination is very important. In case of a beam section, when you draw the bending moment diagram, you would find that the curve is not intersecting at the end, because there is a perception. I would just share my slide again.
There are FRP anchors available for that.
Yes, carbon fiber anchors are available, but I would like to just show it here. So what happens when there is a load coming on the beam? When you draw this bending moment diagram, this would be like this. So there is a point of intersection. So between this point, the strengthening has to be done. So there is no need to go inside, because there is a general perception that the carbon fiber has to be inserted inside the concrete section. There is no need the carbon laminate can be installed directly on the beam section from the edge to edge. And in case if any additional anchorage is required, carbon anchors are available for increasing the end anchorage.
That's correct. In normal condition, carbon laminate need not to go inside the concrete. It is unlike reinforcement steel.
Exactly, sir.
People are used to inserting reinforcement steel inside the concrete. That's why there is confusion. But here it is not required. Okay. Next question is, in case of earthquake or wind stress reversal will be there, then what will be the effectiveness of CFRP?
Very good question. So in my video, I was mentioning that one, there is a dead weight, and then there is an impact load. What happens whenever we are doing any of the structural strengthening design calculation, when you are designing, you would get a checkpoint that whether this is designed for seismic or not. So for seismic or additional wind forces, there are clear guidelines given in ACI 440 code, and using those guidelines, this design can be done. So additional factor of safety is there, which has to be used for seismic or for the wind forces.
In short, stress reversal is not much of a problem. That can be taken care of by properly placing the laminates and wraps.
Yeah.
Right. Next question is for foundation strengthening, is Sika wrap applicable?
So depending upon application, like for foundation, for what application we are doing. In case
this is a little problematic because foundation, unless it is a cantilever foundation or that kind of oblique foundation where there is a cantilevering action is there, then perhaps it can be done. In other cases, perhaps it may not be required. I would say it may not be effective.
Yeah. And the advantage of CFRP is the section size, especially in case of foundation. There is no restriction of going or increasing the section size for the foundation. So mostly for foundation strengthening, conventional method is used. For
whether it is foundation enlargement, then definitely it is not helpful because the section has to be enlarged by concrete.
Exactly.
Right. So probably this question answer requires a very specific consideration why that strengthening is required and whether it can be used or not.
Yes.
So next question is, does the wrap by Sika have an elastic property? Question 1, what is the basic principle? Question 2, how durable is the carbon wrap? Question 3, what is the guaranteed life of the product? Question 4. So there are 4 questions in one.
Okay. So first I take the elongation at break. Like there is no direct correlation for this. So when you design, these are the 3 important mechanical properties which we need for any of the CFRP section. So one is the tensile modulus, second is the tensile strength, the third is the elongation at break. So these are the 3 important aspects. Elongation at break for the CFRP is 1.7%. 1.7 to 2%, 2.1% is the elongation at break for the CFRP members.
It is a very, very highly elastic material. But the confusion is when you say highly elastic, then people think stretchable. It is a reverse. A very high elastic material is very tough and very difficult to stretch.
Yeah.
It's not a plastic material. It's a very high elastic material, just like glass.
Yeah.
And its elasticity is much, much higher than concrete. That's why it's even for a small deformation, it takes very heavy load.
Yeah.
So that is answer to 1. Second is, what is the basic principle?
So basic principle, like the enhancing the load carrying capacity, as I mentioned initially, the loss of reinforcement. For example, first we need to understand for what application we are doing the strengthening. The first slide, what is the region for the structural strengthening, whether we are going for increasing the load carrying capacity or whether we are using it for repairing the damaged section, whether we are using it for modifying, or in case of any
I think the relevant answer is that it is used in 2 circumstances. For vertical member, the principle is confinement.
Yes.
Like say for columns, the FRP is used for confining the concrete, and confinement increases the crushing strength of the concrete.
Yes.
In case of flexural member like beam and slab, it is the tensile capacity of the bottom fiber which is increased by introducing FRP. So these are the basic principle of working.
Yes.
And more cannot be explained in this small time. Then third question is, how durable is carbon fiber wrap?
So Sika has been working on this section since almost like for epoxy, it is working more than 50 years on a carbon fiber, more than 30 years. Like first commercial application was done in 1991 in Switzerland in one of the bridge project. So almost like more than 32 years of the practical application Sika has got, and the test for interlaminar shear failure is happening since more than 50 years, and this is the current available data.
What is the guaranteed life of the product?
So there is nothing called guarantee. The designer has to decide that for what load carrying capacity we are doing the design.
For the product.
For the product, there is like this is carbon metal, this is inert metal, this does not react.
It doesn't deteriorate.
Exactly.
Next is, how do we come to know if there is a serious crack and indication of failure? The wrap is opaque. The wrap is not opaque.
In case if any crack is coming, we need to first identify. In the first session, we discussed about the concrete crack, how it start because of the carbonation, and the complete repair has to be done before we go for a structural strengthening. So two different aspects are there. First, we have to repair the RCC member, and then once the repair is done, for additional load, we can go for carbon fiber reinforced polymer for strengthening the member.
The wrap is opaque. The wrap is not opaque, so you cannot see what is going on behind the wrap system. Now, next question is, how resistant is wrap to the fire? The same has been answered. I think it has been elaborated earlier.
Panditji, I think we have to move ahead. I think because we using time.
Okay, चलिए बाकी का क्वेश्चन अगर बाद में टाइम होगा तो
हाँ बाद में टाइम मिलेगा तो करेंगे.
And thanks for the answer, Mr. Pushpam Kumar. Let's go ahead.
Yeah. Over to Viha.
Now I introduce our third speaker, Mr. Deepanand Bundi. Mr. Deep is a civil engineer, graduate and specializing in construction systems. He is currently representing Master Builders Solution as product management team for the repair, protection and grout system and placed at their Mumbai head office. He graduated in the year 1994 and has a rich experience of more than 28 years in the field of repairs, rehabilitation and waterproofing. He is having hands-on experience in the field of repair and rehabilitation of RCCs and steel structures. He has handled projects like repairs and upgradation of aromatic upgradation of Ras Tanura refinery in Saudi Arabia, rehabilitation of tank farm areas and structures in Godrej Food Refinery at Mumbai in association with IIT Mumbai, and various such prestigious structures. Deep was a part of the various lectures that were presented to UANL in Mexico for engineers and consultants in the country of Mexico in Toluca and Monterrey City in Holcim facility in 2017. He is a life member of American Concrete Institute and was invited by ACI for the Concrete Convention and Exposition held in CA, USA in 2017. He also delivered various lectures on repairs and protection system to recognize forum of Instruct, CCMA, etc. And he has prepared technical report for various national and international structures. I welcome Mr. Deepanand Bundi and request him to start with the presentation. Thank you.
You are not audible, sir.
Deep sir, you are not audible.
या त्यांना फोन करून सांग.
हो हो.
हा आवाज येत नाही.
हा
ओके ठीक आहे. ओके.
So am I audible now?
Yes.
Yes, sir.
Okay, great. Thanks. Good. That's the reason I didn't took up IT. Great. So good evening, everyone, and thank you so much, Viha, for that introduction. I almost forgot what I did almost 28 years back. So thanks for reminding me and taking me back to my childhood engineering days. Very sweet of you. Before I proceed, I would first like to thank my dear friend Pushpam and also Sameer Surlekar sir. I think most of the things you guys have covered with very less background remaining for me to cover. Almost all the basics, and it was good going through all the presentations and all the details that you both have provided. So I guess there's very little less for me to give, but I'll still try my best, whatever I can share. So I'll just share my screen. Please let me know if my screen is visible. Maybe Viha, you can confirm to me.
Yes, sir.
Okay, I'm just sharing my screen. All right, so is it visible?
Yes, yes, sir.
Great. I'll put it on full screen. Let me know if the full screen is also on. Can you see it on full screen?
Yes, yes, yes.
Yes.
Okay, great. So thank you everyone once again, and welcome to this yet another episode of knowledge dissemination, which is being conducted by Epicons Friends of Concrete. I really appreciate the efforts that is being taken by Jayan Kulkarni sir and his team for such a long time. This is yet another opportunity for us to connect, albeit not face to face, but I really appreciate your time and thankful for my earlier speakers who shared their knowledge. Let's hope the topics and sessions are interesting and useful for all of you. Viha has already presented what things I have done in my small time of experience, but currently I serve with Master Builder Solutions and looking after the repairs, protections, and engineering grouts portfolio over there. For the last 3 years, I am with them, right? I'll quickly take you through the dual phase corrosion inhibitors that I'll be presenting today. It's a small capsule. We are slightly crushed on space, on time. So the agenda will be, I'll quickly introduce you what is the service life of a structure and basic introduction to corrosions. What are the dual phase migratory corrosion inhibitors, advantages, their proof of concepts, and then I'll take up any questions that you would like to ask. So generally, if you look at the holistic life cycle solution of a structure that we are talking, I will just open the pointer. So generally, the structural condition is over here, and the life of the structure, all the health of the structure we are talking is on the x-axis. When I construct my building, the health of the building is almost new, it's 100%. And eventually, over a period of time, as I move, my health of the building deteriorates. This is the time when I do my first repairs or rehabilitation of the structure, and I increase the health of my structure to say, per se, 90%. Over a period of time, it again deteriorates, comes down, and I then again do my second cycle of repairs. It goes to 80% and so on. right? So that's how the service life of a building ideally moves. Now, in a very, very ideal situation, I want my graph to move parallel over here. But when I do my first repairs, after whatever inspection, etc., I do, and I enhance the life of the structure or the health of the structure to say 90%, graph should move parallel to the x-axis. And that's how I want my health of the building to remain over the period of time. Now, this service life of a structure, if you look at, primarily, we say that it is divided into three parts. We're talking of a technical service life. Now, what is a technical service life? It is the time in service until which a defined unacceptable state is reached. Probably a spalling of the concrete or safety levels below acceptable standards, failure of the elements. That's where the technical service life of a structure is challenged. We are talking of a functional service life. What is a functional service life? It is a time in service until which the structure no longer fulfills the functional requirements. For example, earlier it is a cold storage where storage of fish or food items are there, and now suddenly that space has been used into an office space. Somebody has rented out to someone else. So the function of the structure has changed. So accordingly, the service life will change. And then there's the economic service life. So what am I talking of an economic service life? The economic service life is a time in service until the replacement of the structure or the part of it is economically more advantageous than keeping it in service. It's better to get it replaced and to continue with it because it's going to degrade further as time passes by. Now, these functional service lives of the structure can be further divided into 4 phases. The phase 1 is like we are talking when you have just constructed the building and you are monitoring the building. A new building, a structure, a commercial office, an industry, a warehouse, a go down, any structure. When it's newly constructed and you are monitoring it, okay, that's when we call it as in the phase 1. The building enters the phase 2 when there is preventive maintenance that you're carrying for the structure, but there is no corrosion initiation. Okay, no corrosion has happened into the building, but it just some pipes, some leakages, some paints, etc. You're doing the preventive maintenance. Your building is in a phase 2. The building enters the phase 3 when there is repair and maintenance at localized corrosion initiations that have happened. Some spots. That time we say the building has entered the phase 3. The structure has entered the phase 3 of its service life. And the structure enters the phase 4 when there is generalized corrosion that happens and spreads all over. By and large, you, me, all of us generally come into picture in either phase 3 or phase 4. Majoritically in phase 4, because that's where the panic button is pressed and all the team members join in, the consultants, the architects, the NDT, the construction chemical manufacturers, the applicators, etc., etc. Right. So these are generally the 4 phases of a service life of a structure when we talk of. And if you look at the amount spent, if you spent about $1 in phase 1, that is during the monitoring phase, it is equivalent to spending $5 in phase 2 when you are doing a preventive maintenance before the corrosion has happened. And if you don't do that, you will end up in spending $25 in phase 3 when you do the localized initiation of the corrosion has happened. And even if you don't do that at that time, you will end up in spending $125 in phase 4 when you go for a generalized repair for the entire corrosion protection that is required. So this is the famous De Sieters law of 5, we call it. The structure says either you give me now, you pay me now, or you pay me later. It's like buying a vehicle and not servicing it. So it's like when you buy a car, you will need to service your car and you need to spend regularly, right? And if you don't do that, your car is going to go into bad maintenance practices, will not give you the mileage and etc. So the concrete is somewhat similar to the vehicle that we are talking. You either pay me now or you pay me later. Now, let's see what are the different environmental conditions that affect the corrosion. I know Surlekar sir has already briefed upon that, but I will just touch upon it. Now, major factors are the chlorides, the carbon dioxide, the sulfates. Majoritarily, sulfates come from water, subsoil, and water itself, H2O. So these are your friends of corrosion. You should avoid these elements primarily from entering your concrete or getting in touch with the reinforcement to form various oxidation states of steel. Two definite problems in corrosion are: the first thing is the corrosion due to chloride induced. So that this is where the chlorides penetrate into the depth of the reinforcing steel and they react with the steel. So the Cl that is there reacts with the Fe to form ferric chlorides, ferrous oxides. O2 will come from H2O, and then there is expansion of the steel bar, and this expansion of the steel bar is going to push the concrete with stress, and that's where your concrete falls. So mostly these are chloride penetrated corrosions. The expansion of the reinforcement bar is roughly measured to more than 600% of an original steel bar that comes. With the various oxidation states that are formed, you can imagine that's the amount of expansion that we are talking about on a normal reinforcement bar. So that's chloride induced corrosion. Then we have carbonation. Now, carbonation is, again, if I get time, I will cover the next capsule, which is on carbonation. So basically, carbon dioxide is there in the air. We all know it's about 4%. And this carbon dioxide, when it reacts with H2O, it forms HCO3, that's carbonic acid. That carbonic acid reacts and combines with the calcium hydroxide and turns it into calcium carbonate. Now, this calcium carbonate, when it is formed, reduces the pH of the concrete. And when pH of the concrete is reduced, your corrosion process is accelerated. Okay. So if you look at a graph over here, when the pH of the concrete, a fresh concrete always has a pH of roughly in the range of 12 to 13. It's a very alkaline material. Now, when my pH of concrete is in the alkaline zone over here, say 12.5, my corrosion rate is 0.05 millimeters per year. The same concrete, when my pH drops to 3, my corrosion rate goes to 0.32 millimeters per year. So my reinforcement bar is getting sacrificed. And just one drop in level from 3 to 2, my corrosion rate shoots up to 0.45 millimeters per year. So you can imagine if I have a 20 millimeter bar as a cover, which is exposed, and my pH of the concrete has gone down. Now, I'm not talking of pH of the chemical that is being exposed, or, don't think of a tank which has a highly concentrated H2SO4 or HCl into that, which is at a very low pH. I'm talking of the pH of the concrete, which goes down, right? So when the pH of concrete is low, your corrosion rate is 0.45 millimeters per year. So you require about 8,000 ppm of chloride to initiate corrosion when the pH is 13.2. And when the pH is lowered from 13.2 to 11.6, the corrosion initiates at only 71 ppm of chlorides. So we're talking of 8,000 to 71 in a drop of about 1.5 units, roughly. Yeah. So that's how important the pH of the concrete is for all of us. We can all check the pH of the concrete at the site level using phenolphthaleins. We all know that. And there are various non-intrusive methods today available. Of course, Kulkarni sir would be suggesting that eventually, if you guys would like to know. So primarily, electrochemical corrosion is a process like a chain. Yeah, it will continue to proceed unless you break one of the links. Now, either you break the link of oxygen, you break the link of water, you break the link of chlorides, you break the link of carbon dioxide. When either of these elements, when one of these elements are not there, corrosion will not happen. The question is, which link do you break? It's practically impossible because all of these are there in the atmosphere in abundance, right? So, friends, you, me, Everyone today are going to sleep, but once corrosion steps inside your structure, that's never going to sleep. It's an electrochemical process which continues and goes on. So 24/7, 365, these cations and anions are going to move through your reinforcement bars as an electrochemical process. Now, this is actually a 12 mm dia bar that I picked up from a water storage tank years back when I had visited MJP in Thana. It was the last stage where you dose chlorine gas into the water for the purification process. And that's where the fumes of the chloride, they hit on the soffit of the tank, and probably it was not protected well, or the cover was too low, a very old construction. But when I measured this reinforcement bar in the lab, it was about 52 millimeters. Now you can imagine over here itself, I see about 400% of expansion that has happened. That's the hand, that's my hand that I'm carrying it. And you can imagine what amount of expansion that we are talking about. So to just sum it up, we are talking of chloride and carbonation attack happening. It lowers the pH. There is expansion of the steel that happens like you saw in the last slide. Development of cracks happen. Obviously, we saw that when there is expansion of steel, the stresses that are developed is going to push the concrete away. It has a more heavy tensile strength than concrete steel, so it's going to exert that pressure on the concrete. Because of that, the concrete cover is going to spall, and when the concrete cover spalls, there is again exposure of the steel, because now the cover has gone, and now there is a direct attack of chloride and carbon dioxide that is happening on the reinforcement bar. So if you see, this is like a circle that is going on. It will keep on going. We call it as the the vicious cycle, and that's where we need to give into and provide different types of protections onto the concrete surfaces. The protections are varying. Corrosion prevention techniques, you can talk of electrochemical systems, like you have anodic protections, you have cathodic protections, you have anodes that are there nowadays very easily available. Anodic protections are already established in the market. In terms of chemical techniques, you have inhibitors that are either mixed into the concrete or they are applied on the surface. You can change the composition of the electrolyte. You have protective coatings today that are available, which are polymer based coatings, which are cementitious based coatings, zinc rich epoxy based coatings. There are pure epoxy coatings, fusion bonded epoxy. So there are various techniques primarily that are available for protection against corrosion towards the reinforcement bars. Now, I'm not going to speak about all of this because it's a very big canvas that I'm exploring here, but I'll stick to certain developments that have happened in terms of surface applied corrosion inhibitors. Over here, I'm talking just one topic. All of these are primarily established. Anodic, cathodic protection, sacrificial anodes, we all know about that. So I'll be discussing on corrosion inhibitors. So what are inhibitors? They are primarily the chemical compounds that are added to the electrolyte to decrease the corrosion rate or alloys, and after migrating to the porosity of the concrete. We all know that concrete is a porous material. Yeah, it has good amount of pores, and through this pores, if I allow these inhibitors to pass, because they have very high vapor pressure, they will penetrate inside the concrete, and they have affinity towards steel, so they will move towards them. So what are the requirements of a corrosion inhibitor we are talking about? We are talking about these corrosion inhibitors when you apply on the surface of the concrete, either after the repairs or on a new construction, right? You should be able to control both, as I said, corrosion due to chlorides and corrosion due to carbonation. It should be effective in good humidity area. In India per se is a good humid area. If you talk about, we have a good coastal line. It should change the electrical properties of the steel. That means the I-core value should be in control and very low. The current passing through it should have a good service life and should be effective on concrete which is having cracks. So there are, maybe after you cast your concrete wall or a retaining wall or a structure where concrete is going to crack, it's a brittle material. So I should have my protection that should be able to prevent the corrosion even after the concrete has cracked. The performance should be proven by lab tests, and the functionality of the inhibitor should be proved, of course, at site itself. So if you look at the technological overview, I'm talking of a dual phase corrosion inhibitor, which offers state-of-the-art protection for your reinforcement bars. Now, what is the highlight over here is I'm talking of a dual phase corrosion inhibitor. What does that mean? It means that it's a revolutionary blend of high quality silane and an additional corrosion inhibitor. Now, what do silanes do? Silanes are very good water repellents. So when you apply the silane on top of your concrete, they are going to remain on the surface, and these molecules with high vapor pressure with corrosion inhibitors are going to penetrate inside. It delays corrosion and reduces the active corrosion even on cracked concrete. As I said, it's effective against both chloride as well as carbonation-induced corrosion, significantly reduces water ingress, and strengthens the passive layer on the reinforcement. So it goes and forms a layer on the reinforcement bar, increases the resistivity of the concrete. These are the important highlights. The requirements are to be a clear liquid that when it is applied on a hardened concrete combines the power of a penetrating inhibitor and a latent phase inhibitor. Right? Even
Sir, we can't hear you. Deep, sir.
Sir, your voice is lost again.
माणूस कळतं पण नाही याला बोललेलं.
Sir, your voice is not there. He is reconnecting, I think. Yes.
you can hear me now?
Yes.
Okay,
yes.
I think there is some issue in my Wi-Fi probably. So please allow me to share my screen and just let me know if it is visible, sir. Okay. So is my screen visible now? Can you just confirm?
Yes, yes, it is visible.
I'm going on full screen. What are the requirements of these dual phase migratory corrosion inhibitor? The first thing, as I said, should be a clear liquid and combines the power of a reactive agent, a corrosion inhibitor, and a latent phase inhibitor. That's when it goes inside, it should be able to penetrate and protect the reinforcement bar. So basically, this is a nanotechnology which combines the benefits of silane. Silane has a very small molecular size as compared to other coatings or paints, and combined with latent corrosion inhibitors, so it remains active inside the pores of the concrete and still remain even if it cracks at a later stage. Single component, nothing to mix, nothing to do, just open the container, apply it. Very easy at the site, because we have challenges in application. We have people at site level with their intelligence level. We do not want a very complicated application process per se. So that's very important for us to take care of it. Then it should also have easy to spray, single component, and should not change the concrete appearance, user friendly, non-hazardous, should have a high flash point. And primarily, if you look at it, coatings, if you're talking of 200 microns, the silane, we are talking of 1 nanomicron over here, and silicon siloxane is something like that in 20. So we have a very nanotechnology material that penetrates inside, right, and gives you the protection, even prevents the corrosion even if it has already started. It cannot reverse it. I'm not saying that your corrosion that has already happened, or if you have a half skill reading, it's going to reverse it, but it's going to prevent any further corrosion from happening. We did actually some tests in a few of the port sites, because a port is something, or a jetty is something to alternate wet and dry splashing conditions. So we've got some very encouraging results over there. So that's how the surface applied corrosion inhibitor is going to work. When you apply it on the surface, it's going to penetrate inside and protect the reinforcement bar. Okay, so if you talk of these, primarily employs dual functionality. As I said, the silane base provides similar to water repellency that you get, and corrosion inhibitors are carried into the concrete along with the silane. So what happens are the pores of the concrete also get coated with silane. It avoids any water from going inside, because H2O is one of the important ingredient that you need to avoid from entering. So it provides a barrier towards that. The inhibitors remain in the concrete until the repellency diminishes or the concrete cracks. And once it cracks and new water comes in, the inhibitor moves with that water and still keeps on penetrating and protects the steel. All right. And then they provide excellent protection not only on uncracked concrete, but also on cracked concrete or possibly concrete that may crack in the future. So because of its dual functionality, it guarantees efficient and long-term protection. I'm sharing a small video. Let me know if the sound is visible. Sound is audible. I'm sorry. Can you hear the background sound? Yeah, so it basically showed two types of exposure levels. The first is when your regular concrete is damaged and you repair it, and then you apply the surface applied corrosion inhibitor in the green form that you saw, and how it penetrates inside and provides a layer on the reinforcement bar. Eventually, as time goes by, when there is wear and tear of the concrete surface and the surface cracks, the chloride ions or the oxygen ions, they come inside, and the active ingredient of the corrosion inhibitor, it reacts with that and again protects and does not allow any corrosion ingredient to go inside. So that's how the dual phase corrosion inhibitor primarily works. I'm so sorry, it again started. Yeah. Okay. So what are the advantages and benefits of this? If you look at, I'm talking of a dual phase surface applied corrosion inhibitor. The first thing, as I said, it's a very micro technology, nanomolecules. They penetrate very easily for protection, even in case of post application of the cracks. Surface remains unchanged. You know, your profile of the concrete surface does not changes. The delays the active corrosion, effective both against chloride and carbonation, and it's very easily possible that you can apply a protective coating on top of that. For example, you need to paint, you can do that. It doesn't affect the bond strength of any material remaining over there, and overall the life cycle cost of the structure comes down with very low operational downtime. So if you look at it, it extends the service life overall of your concrete structures. Which all places you can apply? Of course, there are high-rise residential structures nowadays with all MI1 buildings coming up along the coastal road, coastal zones, and there's a lot of chloride deposition rate. CDR is very high in these areas. Marine structures such as jetties or the ports where you have alternate splashing, wet and dry cycles, industrial structures or silos, infrastructures where they are exposed over to various marine climatic conditions or coastal exposure conditions. The application pretty much very simple. I will not take much time into this. These are the basic fundamentals before you apply any of the coatings. So your concrete should be properly cured, surfaces should be dry. The reason I'm saying dry, like this is not an epoxy coating. So there is no mandate requirement that, it's not a solvent based coating that you should have a dry surface, but it's better to have a dry surface. The only reason is the better it is for the ingredients to penetrate inside. So if there is water or humidity or a damp surface, your effectivity of the product will reduce, and eventually you may have to apply a little additional coat in case of that. So it's always better to have a dry surface. There is no adhesion or there is no loss or anything per se, but it's only to enhance the performance. Your any delaminated or spoiled concrete should be repaired, cracks should be filled up and treated, and only then you should apply this. So that's basic substrate preparation that should be done. The generally CSP, the concrete surface profiles as per the ICRI guidelines are CSP 3 to 5. It's much better to have them. There is not much high quality of protective gears that are required. Basic personal protective equipments like helmets, jackets, gloves that should be used. Atomizing sprays can be used. You can spray it. These are various different ways in which it has been applied. Non-atomizing or atomizing with pressure. You can try that, any of these equipments, which are much better. The application methodology is pretty much simple. Open it as it is. There is no dilution. It's a ready to use material. So at site, there is no much of an issue. Protect surrounding areas in case if there is something to overspray, and apply it on dry concrete, as I said, for better penetration. Allow it to penetrate inside, and maybe after 15 to 20 minutes, you can apply the second coat. Generally, we recommend a minimum of 2 coats, any protective coating systems. If they are highly exposed conditions like coastal regions, we can say maybe apply an additional coat for better penetration. You can see these applications. Mobile equipments can be used to spray. Proof of concepts is we have tested the products in various labs in Spain, in Germany, in US, and with the Federal Highway authorities. So these testings have been elaborately be done in terms of exposure conditions for chlorides as per ASTM G109. You can see the setup. I have got an extensive report on that. So I'm not sharing everything over here, but the specific ones, like you see, as per ASTM G109, the specimens were coated with 2 different silane-based surface applied corrosion inhibitors. So on the left graph that you see, the specimens had been cast and cured before applications of 2 different surface applied corrosion inhibitors. The one in the blue is the dual phase corrosion inhibitor that you can see here. And the red one is the uncoated. So if you see in terms of the coulombs that are being passing, it is almost 0. So there is no corrosion activity that you can see over here in the graph. In the center graph, if you see, the specimens have been ponded for several months to initiate corrosion. So what has happened here is, here we have already made the reinforcement bar to corrode in this case. And then the surface applied corrosion inhibitor was applied. And you can see on the, in terms of corrosion activity, it is very high on the uncoated bar. It is marginally low on the amino functional silane, which is another product from MBS itself. And this is the advanced dual phase. This is the single phase and this is a dual phase. So after initiation of corrosion also, the further growth of the corrosion is very curtailed in terms of what amount of charge is passing. And in terms of the last graph also, you can see in terms of non-corroded and cracked concrete. So in cracked and uncracked concrete, the untreated portion in terms of corrosion activity is pretty high, and in terms of cracked concrete, it is almost zero. Okay, so this all has been done as per ASTM G109. With the Federal Highway Authorities, we have checked the samples. The one in the blue that you see in terms of this is the sample 1 and sample 1, which is pre-corroded. So corroded reinforcement bar, what is the coulombs that's happening, and this is on the non-corroded. In the gray area, you can see is a different sample of another company available in the market, and the orange one you can see are the corrosion levels of, you can see over here is the pre-corroded and non-corroded. Yeah, so the non-corroded is over here and the pre-corroded is over here. So if you have a dual phase corrosion inhibitor, in terms of application, after 3 months of corrosion, your corrosion initiation is almost parallel to the x-axis, and that's what we are going to need it prima facie. Proof of the pudding is, of course, in having it and tasting it. So these were all the lab tests that we have done. But as I said, we did conduct a lot of testings in terms of on-site performance also. Now, these are various instruments that to detect the location and to check the resistivity and the half cell potential and the corrosion rates, the speed at which the corrosion happens. So anything more than 1 microampere, we say it is severely affected, and anything less than 0.1 microampere, we can say that there is no forecast or future damage that is expected. So in terms of in terms of the ICOR values, that's how your corrosion is going to happen. So on the Dallas courtyard, we did the LPR rates. Basically, this is in US, and we did the linear polarization rates on untreated and treated surfaces. So you can see the untreated surface, and this was done after 2 years by an independent third-party lab over there, and that's the results. Because all details are available, I cannot put up everything over here, but I can share if in case anyone would be more interested into this. In one of the ports in Spain, we did the application on the concrete surface which is exposed, and in Gion in Spain, another ArcelorMittal factories, we did the application. In one of the one of the ports, when we checked at the same point, there were 4 points on which the readings were taken. So if you look at the concrete resistivity drastically increased at all the 4 locations over a period of 1.5 years. This was done in 2018 and 2019. So at all 4 locations, the concrete resistivity increased in terms of protection. The half cell potentials at the same locations at point A, point B, C, and D, the half cell potentials decrease. Over here you can see, and in terms of the corrosion rate, in terms of the ICOR values, as I said, in terms of microampere, they were almost coming to zero over a period of 1.5 years after the testing was carried out at all the 4 locations in this port. Now, mind why I'm saying port, because you can appreciate that these are very high corrosion exposed areas, and that's where you will have maximum chlorides getting deposited, and that's where the concrete needs the max protection. So that's where that's the reason we tested it over here. One of a small video again of how it looks, and after application you can see, because of the silane, see the water is not getting penetrated. You can see the silane. This is actually applied in one of the sites in Mumbai. Yeah, so that's how it looks like. Just to show you the repellency of the product. Yeah, various technologies are again available. We just try to benchmark it. You have pure silanes, you have amino functional silanes, you have amino carboxylate silanes, you have amino alcohols, monofluorophosphates, and water-based systems. So these are more of the functionalities and how they behave. Now, in terms of all these technologies that are available, when you compare it with a dual phase surface applied corrosion inhibitors, they definitely are by far much more efficient against chlorides. Carbonated concrete, efficiency in pre-cracked concrete. So even if your concrete is cracked, you will have very good protection, long-term efficiency, ease of handling, and health and safety. So if you compare it with amino functional silanes, amino alcohol silanes, or water-based protections, you will always have a better edge in terms of performance of this coatings. And if you look at what are the benefits as a specifier, if you are, or as an asset owner, if you have your own assets and you need to protect it, so the important highlights for the product are because they are nanomicrons, they penetrate very easily, and the silanes will give you water protection, water repellency. The surface remains unchanged. It delays the onset of corrosion and reduces active corrosion very significantly. You can see the half cell potentials at the same point have reduced drastically after the application. They are effective against chloride and carbonation. I have an extensive reports available. People interested can get connected. I will share. And most importantly, you can apply any aesthetic coating in case you need to do that. And it minimizes the maintenance cost over a period of time. So if you calculate the life cycle cost analysis of a structure, it's definitely going to help and extends the life cycle of the concrete structures. These are few benefits for asset owners or the clients and the specifiers when they look at it. In terms of applicators, they have their own benefits. It's a proven corrosion protection even in case of post application of the cracks. Even if the concrete is cracked and then you apply it, you will still be getting the benefit of it. It's ready to use, so you don't need to worry about mixing or diluting or weighing it at site. So in terms of application, it becomes very easy. It does not require any high cost equipment. It's pretty simple. You can apply at an Indian level. You can even apply it by a roller or a brush, and it penetrates inside. It's easy application. Two packages are available in terms of packing sizes. Possible to apply a protective coating again, and importantly has a very low VOC also and a high flash point. So having a very low VOC also is very important because of the fumes not getting into the labor, and it helps us. So friends, that's what I had to share on this topic. I would ask if any questions more on that, I'm ready to take. Thank you so much from my end.
Thank you, sir. We will take some questions which are there in question answers box. Mr. Mangesh has asked, how can we estimate dosage of corrosion inhibitors, or how can we estimate spacing of inhibitor caplets?
Yeah, so dosages are generally given by us or by the manufacturer, whoever is manufacturing it. Generally, the dosages are on per square meter basis. So you generally apply about 0.15 to 0.2, 150 grams, 200 grams per square meter, depending on the absorbency of the concrete. That's the range, or it may slightly increase or decrease by about 50 grams here or there. And that's what you need to apply. If you apply a dose of about, if you apply 2 coats, so your application dosage can be say about 0.3 to 0.4 kgs. That's 300 to 400 grams per meter.
Has it got some relation with reinforcement? Deepananji, whether dosage has some relation with reinforcement? Quantity of reinforcement? आवाज नहीं आ रही है आपकी, आवाज नहीं आ रही है सर. सर आवाज नहीं आ रही है.
सर आपका आवाज नहीं आ रही.
डिस्कनेक्ट हो गए. अब आप यू टेक ओवर एंड
I think he has got disconnected. Yeah. So he is there. Hello. Deepan sir, you are there? Can you hear us?
Can you hear me?
Hello.
Am I audible?
No, sir. Just
Yeah,
I
right.
got.
Abhi chalu hua.
Now you are audible. Now you are audible. Yeah.
I think there is some issue with my Wi-Fi or a network or my laptop, because after some time it stops the audio. Yeah. So are you talking of in terms of the density of the steel that you are talking in terms of
Yeah.
Yeah. So generally that's why we give a range. Like, you know, if your density of the steel, basically we look at the porosity of the concrete, and based on the results that we have done as per the ASTM G109, amount of penetration that we have established at different dosages. Like, you know, we did the testings at in 2 codes at 0.3, at 0.4. We did it in 3 codes at 0.17. And so like about 0.5 kg per square meter.
It's a basic function is these nanoparticles reach to the reinforcement and they coat the reinforcement. So whether it is related to surface area of the reinforcement, both the thing, doses of the inhibitor as well as doses of the capsules.
Yes, because the reason, because the reason is it's not only about providing protection to the reinforcement, it's also about filling up the pores that are there to avoid any H2O penetrations. So, you know, as I said, it's a dual phase one, which is having silane as well in that. So the silane is also going to help you to coat the pores through which it's going to pass and prevent, I mean, we all know the benefits of water repellency not going inside, and eventually that's how your service life of the structure enhances. That's what we call it as like, you know, a dual phase protection. Yeah, that's pretty much it, Pandey sir. Yeah. Anything more? Any more questions, sir?
Now there is one question, Popat. Can it be possible to predict service life after repairing the concrete structure considering durability aspect? Well, the simple answer is it's almost impossible.
Yeah.
There are many mathematical approach to predict service life, but first of all, you have to define what is service life, one. Then you have to find out what is the method by which the deterioration is taking place. That is, what is the damaging?
I think, sir, you're also talking of the exposure conditions that we
exposure condition. What is
exposed to?
No, what is the process by which concrete are reinforced?
Whether it is carbonation, chloride attack,
whether it
is combination of both, all the things come into picture.
Whether it is
nothing to do with only putting.
So these various models are there, but it's not really very easy that you can simply say that after service, after repair, it will be 10 years or 15 years or 20 years. It is best a guesstimate by a qualified person.
So
now, next is
Pandey sir, can I put a one-liner joke over here?
Yeah, sure.
Can I ask that will I be happy after I get married? Sorry.
That's correct.
Yeah, sorry. So it's pretty much yeah, there are calculations like sir said, but they pretty much vary. There's a Life 365 software that's available, but pretty much depending on the exposure conditions, it will vary. It's a very varying technology that
because first of all you have to assume certain rate of action of chloride, rate of action of carbonation.
Yeah,
that itself becomes a problematic situation. So there are a lot many assumptions are made. It can help only to knowledgeable people. It cannot help to, I mean, say that simply you put certain data and take out a figure.
But I still need to get
kind
married,
of thing
right?
is not there.
But I still need to get married, right?
Yes, that's correct. That's correct.
Right, sir. Sorry, that was on a lighter note. Please explain.
One more question is to Mr. Pushpam Kumar. Would like to know more about Sika Plastocrit Super that he has asked earlier also. Yeah, he is there. Pushpam sir, you are there?
Yes, sir, I'm there.
Yeah.
This is basically an integral waterproofing compound, and this is used for increasing the workability of the concrete. Though I'm not the expert for this product, but the basic is it's just a additive for concrete workability.
I think there are no more questions as such. Pandaji, you want to add something with some questions, or we close it by our vote of thanks?
We close it by this thing.
Yeah,
because there are few questions, but that it will take long time to answer. Because it cannot be answered so easily.
Yeah.
There is one question like beam column joint, how to take care once beam and columns are strengthened. So in fact, FRP coatings are FRP wrapping is quite useful for strengthening the beam column.
Yeah, correct. It is much more. They are more than members. Better you can do joint strengthening by them much more effectively.
Correct.
Yeah.
There is a question in practical case. Slab is obstruct the shear wrapping. So how to do in practical case? There are sketches for this kind of situation, because most of the time there is slab on either side of the beam or one side of the beam. So fiber wrap ends are embedded into slab. There are shear anchor for that. So there are methods to make it.
Okay, fine. So let's close it. I'll do my customary duty to offer a vote of thanks to all the three speakers who took out their valuable time to attend and address this semi-webinar, and to all the more than 75 participants and more than 52 are still there with till the end.
And Mr. Nagargoje,
special thanks to them. Yeah,
Mr. Nagargoje
our
for
chief guest, Mr. Nagargoje,
motivating us.
for inaugurating us and motivating us for this. Actually, this particular webinar was basically arranged for his placing or for his their requirements, and our gold sponsors, Mr. Gopi Civil Engineering, our silver sponsors, Mr. Building Diagnostic Solutions, and last but not the least, they are our all Epicons Friends of Concrete volunteers. We are having our next webinar on 19th November 22. This is on structural design related issues. That is discussion on structures for all buildings. So most useful to the structural engineers who are present here. With that, I think we close this webinar, and thank you all.
Thank you. Thank you, Kulkarni Sahib. Thank you so much. Thank you, all of them. Have a good evening and a good weekend. Thank you so much. Bye-bye.
Thank you.
Bye.
Thank you. Bye.
Bye-bye.